Oh yes. It's Brady.
Caw.
And Levi.
Levi.
Do the bird noise.
Caw.
Caw.
Nerdish.
It's nerdish with a 3, not nerdish with an E. Why?
8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Yes, because nerdish with an E was taken.
And that's why we do it 8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Thank you for giving that reason for a question that I didn't ask.
That's sort of like the way we eliminate answers on the reading section.
Yeah, that's true. And I guess the other sections to a certain extent.
I think it's important when doing a rap to listen to the beat that's happening in your ear. Otherwise, you have a problem staying on beat.
Correct. We do the ACT and SAT, they're standardized tests to help you get into college.
We don't tutor rap. We shouldn't ever do that.
No, we're not pretending to be tutors of rap, even though we're really good. Sometimes you can be really good at something, but not be a good teacher. Case in point.
Point in case.
Point in case word.
Point in case something bad happens.
Like this?
Yes.
I think we're enriching your lives by you watching this.
I'm getting a phone call from a friend. Do you think I should pick it up now?
The phone call just was dropped. Maybe he'll leave you a voicemail.
Next time, I'll pick it up during the stream. That way we can all talk to my friend Steve.
If you think this is not very high quality, don't worry. We're gonna do it again in 2 weeks.
Also, we're much better quality when we're teaching you all the things in a number tree.
Like prime factorization?
Yeah.
Oh, that's fun.
Yeah.
You break a number down into its prime parts until you can't break them down
We
anymore.
should probably do that right now.
Yeah, we're gonna
okay, so let's say 32.
I was gonna say 30. That's so close.
Oh my gosh.
All right, break it up.
Okay,
Any way
okay.
you want. 2 and 16.
Okay, 2 and 16.
2 and 16. 16 is 4 and 4.
Okay, 4 and 4. Oh,
And
interesting.
each
So
4
16
is
a perfect
2,
square.
2. Yeah, exactly.
Okay, 2 and 2 and 2 and 2.
So it's 2 to the 5th.
Yeah, it's 2 to the 5th.
2 to the 5th, exactly.
Whoa.
Yes.
That's pretty cool.
You see that? It's that quick. Now you know. Think about that for our whole show.
Now stop watching the stream because you've learned everything necessary.
Bum, 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 bum. We're in a box. You can help us by asking us questions in the hope that someday we can escape. Okay. Cram session time. There is an ACT tomorrow morning, and everybody is talking about it. It is the talk of the town, the buzz of the neighborhood. The ACT is tomorrow. If you have questions, now is the time. I have a bunch of topics I can just go into, and I can start talking about them. But this is for you. It's not for me. I am for you. You are not for me. Right? Good. So, does anybody have any questions? You can ask them right there in the chat. We have a Discord. The link is below. Hi. L. Wayne. Long time no see. How's it going, L. Wayne? Ivanikar. We're going to have to set up the essay again. Oh, good question. Ivanikar, hello. Haha. You're the one that just wrote about the essay. So, we have the essay. Okay. Hello, hello. Let's talk about this essay. All right. I'm super busy, but I'm taking the ACT tomorrow. Yikes. Oh, we got to just, okay. Let's take a look in the Discord. Ivanikar, the essay is a big question, so I will get to it. I'm going to answer this math question first, though, because it's not going to take as long. Okay, L. Wayne. Number 44, I'm guessing, because that's the only one that is fully on there. Let's see what we got here. All right, so we have this line. We got that line. We have this, this, and this. And we have A, B, C, as easy as 1, 2, 3. That's a good song. Okay. Line 2, line 1. See, this question is. Lines L1 and line 2 intersect each other and 3 parallel lines. Line 3, line 4, and line 5. All right. One thing I'd recommend for geometry questions is if there's not a picture, draw a picture. If there is a picture, label the things they're telling you if they're not obvious. This is obvious. Line 1 and line 2 intersect line 3, line 4, and line 5. That's great. The ratio of the perimeter of triangle ABC to the perimeter of triangle AFG is 1 to 3. All right, now we're getting somewhere. So we have triangle ABC, and we're going to say perimeter to the perimeter of triangle AFG is 1 to 3. That's very interesting. The ratio of DE to FG is 2 to 3. What is the ratio of AC to CE? Ratio, that's what we're looking for. Okay, let's see what we got here. So, the ratio of the perimeters of ABC, which is this triangle right here. So that triangle compared to AFG, which is this big one. I'm going to draw us, here we go, triangle. We got some nice orange lines. All right, that's okay. It's 1 to 3. All right, what that tells me, these are parallel lines because they said they were. So what we have here is a bunch of similar triangles. Let me just make sure that they did in fact say that they were parallel lines. Yes, they are. Yes, they are. Okay. How do we know that these would all be similar triangles? Because they all share this angle right here. All right. All of these lines are parallel, so all of these inner angles are going to be the same measure as each other. And if triangles share all the same angles, it means they're similar, which means you can use proportions to solve for side lengths. All right. That chain of logic, you got to get that down. Similar triangles, proportions. That's just what this question is, and many questions about triangles are about. Okay, so the fact that the perimeter of this to this is 1 to 3 tells me that the ratio of all the side lengths of this small triangle to that large triangle will also be 1 to 3. That's the only way that that could happen. And then the ratio of, we have DE to FG is 2 to 3. What is the ratio of AC to CE? All right, that's great. That's so good. Well, let's start giving ourselves some variables. So we're going to call this X, call this Y, call this Z. Those are the side lengths of A, B, C. And then the side lengths of AFG are all going to be 3 times as large as that. So this right here, I'm going to get rid of some of this lineage. Here we go. Let's get rid of this. Get rid of that. These things go too far. You go too far, lines. I must put a stop to you. I should have killed you when I had the chance. This right here is going to be 3x. This is y. This right here is going to be 3y. And then that z, this right here is going to be 3z. All right? I don't know what x, y, or z is value-wise, but I can call them what I want as long as I keep the pattern of all of the larger, this large triangle will be 3 times larger in all of its side lengths than this one here. Great. So that right there is now labeled. I don't need to think about it anymore because it's now in the diagram. The ratio between DE and FG is 2 to 3. So DE to FG is 2 to 3. Now this is quite fun because I already have FG labeled as 3Z. So I can piggyback off of that and call this 2Z. 2Z. Okay? Because the ratio of... Okay, this marker is not great. I'm going to put it in my pocket and forget that it's not great. Because then I can take it out later and have the same exact situation. The ratio of 2z to 3z is simply 2 to 3. Because ratios are like fractions. You can simplify them if there's a common factor on both sides. So if you have the fraction 2z over 3z, z is on the top and bottom. You can cancel both those out. You get 2 to 3. Okay? Oh, look at that. Thank you for linking some people there. That's kind of fun. Okay, so we're almost done here. So we have 2z to 3z. That's super helpful. What is the ratio of AC to CE, which is this very last part? Ah, okay. Okay, very interesting. Very interesting. Well, here's what I'm seeing. There are 3 triangles to look at. We have this small one, we have this medium one, we have this large one. We know that the large one is 3 times bigger than the small one, which is why we have z and we have 3z. The fact that this is 2z right here tells me the ratio that the middle triangle is compared to the smaller triangle. It's twice as big. If this is 2z and that's z, the bottom side is twice as large as this, which means that these side lengths will also be double these ones right here. So if I zoom in here, and let's say I look at just, this is going to be weird, from here to here, right there. All right, that's going to be twice what this distance is, because this triangle is twice as large. So this right here is going to be 2x. All right, this right here is going to be 2y. All right, here's the fun part. AC is y, we already called it that. CE, right here, is going to be the difference between this overall side length of A to E minus AC. So if this is going to be AE minus AC, we know that AE is 2y. We subtract AC, which is y, and we get another y. So this little segment in here is y. And therefore, the ratio of AC to CE is y to y, which simplifies to 1 to 1. Let me just make sure that that is an answer, and then I will feel more comfortable with this. 1 to 1. Yes, I am pretty sure that that's going to be the answer. Let me know. L. Wayne, yes, that is correct. I circled wrong. Hey there. Slayer Darth. It's going well. My pal Levi's not here because he got his schedule messed up, and he forgot that we're supposed to have a cram session. Probably shouldn't have said that, Levi. But Levi left me out to dry, and now I'm extremely dry. That's what's happening. That's what's going on with me. You're finding me in a very, very dry state. Okay. L. Wayne, sounds like you got that. Very, very cool. Okay, so we have essay. That is another question that's on the queue. And then we have a Discord. Please put things that you want to talk about on the Discord. We have as much time as you guys need. I will teach as long as you guys are up and willing to learn. However, disclaimer, if you're taking an ACT tomorrow morning, you need to sleep tonight. That is incredibly important for your clarity of mind tomorrow. So do not stay up too late watching this. I will not go too late doing this, but there are people on the West Coast that, oh, we have a new question. We have a new question. Gotta let it dry. Ivanikar, are you still there? I want to talk about the essay, and then I'll start doing other questions. Just say hi. I just suck at visual stuff, I think. Ivanikar, very good. Very good. All right. Okay. Okay. Let's get rid of this stuff. Good. Good, 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 good. Good, 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 good. Very good, very good. Okay. Mm-hmm. Absolutely. It's a lot. This is a dirty board. Got to erase all over it. Okay. Okay. So the essay. Essay time. There is a prompt, which is in the form of a question. And then they give you 3 perspectives. Perspective 1, perspective 2, and perspective 3. And your job is to come up with your own response to the prompt, but include the perspectives. Now, some of them you might agree with, some of them you might disagree with. You have to acknowledge all of them, all right? So one, let's just make up a question here. A question might be, I'm going to go with the classic school essay on school uniforms. Should we make kids wear them? Okay, so here we go. Should we wear school uniforms? Question. Good old school uniform essay. We love that. Perspective 1 might be, let's see. So, freedom of clothing, as in what you choose to wear, not choosing to wear clothes or not. Freedom of clothing, weird way to say it, allows students to express themselves. Okay, that's perspective 1. Perspective 2 is going to be, there's always the idea that you can tell the socioeconomic background of some certain students because of the clothing that they wear, whether it's very expensive clothing or not expensive clothing, and that uniforms equalize it and make those differences. Slayer Darth, please, this is an open classroom. Let us know. Okay, perspective 2 might be that uniforms erase social class markers. All right, that might be his perspective. And then perspective 3 might be, oh man, uniforms. What might perspective 3 be? Those are usually the two big, let's see, it's less stress for a student to choose the clothing they have to wear. In the event that they commit crimes against members of the general public, it may be difficult to identify them. With them not wearing school uniforms, is that in the event that they commit crimes against members of the general, it may be difficult to identify them. Do you mean if they do wear school uniforms? Or, okay, if they wear school uniforms, it's easy to say, oh, that's a kid from PS 137. Is that what you're saying? Or if they don't wear school uniforms, it's easier to identify them? Because I think I understand what you're saying. Can you explain a little bit more? Perspective 3 is going to be, this always happens. Yes to what? Which thing did I say are you saying yes to? Perspective 3, okay, we'll go with Slayer Darth, which is, we had an issue with some local teenagers harassing our office. And if they had school uniforms on, then you'd know which school they're from. Is that what you're saying? I want to make sure I have that right. Do I have that right? Let's see. Slayer Darth, I'm counting on you. Do I have that right? And as they were not wearing school uniforms, it was difficult to identify them from the CTV. Oh, okay, sure. Okay, so school uniforms make students easier to identify. Okay. And being easy to identify can help in a lot of different situations. Okay, so the first thing you're going to want to do is think about your own perspective on this issue. It doesn't need to come from the heart. You could just be the side that you're more interested in writing about. It's sometimes fun to go against what you think you're about and try to argue from the other side. You're playing devil's advocate. It makes you a better debater and a better thinker. So my perspective would be, so I didn't go to a school with school uniforms. I dressed myself whatever I wanted to wear growing up. So I think it'd be fun to argue the opposite, is that we should wear school uniforms, okay? So first thing you want to do is write some kind of a hook that makes your introduction easier to get into, all right? This is just general essay practice. Don't think too much about it, but you want to pique the reader's interest. You might say something like, maybe reference the current inequality that seems to be, increasing every year. Ivanikar, you have to mention each perspective, okay? So you have to identify the ones that go for your perspective and the ones that go against your perspective. So the ones that go for my perspective, now I'm going to say yes, we should wear school uniforms. Then this is for my argument. This would be against. And then this right here makes students easier to identify. So this is a good thing. This would be for. Okay? Yes, you have to mention all three perspectives. Okay? Typical essays, it doesn't mean that you have to write it like this, but typical essays are like a 5-paragraph essay. You have an intro, you have body paragraph 1, you've got body paragraph 2, and you have body paragraph 3. One of my former viewpoints is when I came to writing an essay. Write your introduction with your regular closing and then start the middle of the essay. Oh, that's interesting. Yeah, I like that. I like that a lot. All right, then you have conclusion. You have a limited amount of time to write this thing, okay? I think you only have 40 minutes. I should know this off the top of my head. Let's make sure of that. ACT essay. Here we go, here we go. Is it 40 minutes? Is it 40 minutes? Please tell me that it is 40 minutes. Come on, come on. Here we go, here we go. Come on, come on, come on. Okay. Now, yes, you don't have to actually say, perspective 1 says this, perspective 2 I don't agree with. No, you don't want to do that, but you just want to mention what they're saying so that you address their ideas. Okay, so here is the actual list of things that you need to do. Okay, so we've got, here we go. Number 1, analyze, and this is not a good marker. There we go. Analyze and evaluate the perspectives given. You should take around 5 minutes to just plan this thing out, okay? Think about what your perspective is going to be, because you do want to sort of create your own perspective here, and you want it to be somewhat nuanced. So don't just say, yes, we should wear school uniforms. Say something interesting about why you think it's really, really important to wear school uniforms. But you will be using these perspectives. So analyze and evaluate the perspectives given. Analyze means break apart, okay? You need to think about what each of these perspectives is saying. Think about, do you agree with that? Do you think there are holes in that logic? Do you think that logic is perfect? And evaluate is basically say, yes, this is a very good argument, or this is not a good argument. I would recommend that your body paragraphs, roughly, they don't have to, but I would say the simplest structure here would be have each of your paragraphs address one of the perspectives. I would say that you want to try to prove your point here. So you definitely want to start with one of your paragraphs that are for, okay? For. And then, in this case, I have 2 for and 1 against, so I think it'd be nice to make a nice little sandwich here. For, against, and for. Okay? The next thing you need to do is state and develop your own perspective on the issue. So what they're looking for here is that your perspective should not be just a rehashing of one of these perspectives. It should be something that is coming from you. It might be some interesting mix of these. It might be something that's totally new. It could be something that's totally new. You might have another reason why you're totally for school uniforms, and that's great. So you should have your own perspective on this, and it could be a slightly, twisted, not twisted in a bad way, but like a slightly, mixed around version of these perspectives. But try not to just say exactly what the perspective is and, claim that as your own. You want to have your own perspective. And the last thing you want to do is explain your perspective. No, sorry. Explain the relationship. between your perspective and the perspectives given. This is an argumentative essay, all right? This is a persuasive essay. So it sounds like, I mean, there's a lot of stuff on the board right now, but really you're coming up with your answer to this question. You want a very clear perspective, okay? If they can't find a sentence that's like, this is exactly the crux of the argument, you're doing it wrong, all right? Your introduction should have some kind of an interesting hook. Maybe it's the story about, you know, the students that, you know, like Slayer Darth was saying that they, what did they do? They harassed an office and they couldn't identify them because they didn't have, you know, uniforms on. And then that your story about that is a really, really interesting story that brings the reader in, okay? So your introduction, I'm going to put it up here. So your intro paragraph should have a little hook, a little fun thing that comes from your life, how you relate to this thing, and then it should have your thesis. Is first person okay then? Yes, I would say first person is okay. If it's a story that involves you in the beginning. Otherwise, for the rest of the essay, I would not necessarily use I, because it's not a narrative. You might use a small narrative as your hook, but then the rest of it is you're trying to persuade the reader of something, which you generally don't keep saying I. It's not really what you typically want to do. All right, so your intro is a hook, and then the thesis. What if you bring an example? Yes, exactly. That's exactly what you can do a little narrative example. That's fine. But generally, to build credibility, you kind of want to sound more objective on a subject. Yes, I would say probably try to refrain from doing that in the bodies. I think I don't want to make that a hard and fast rule, though. If you got a great example, then I would say probably go for it. But typically, if you want to build credibility, you want to sound like a detached professional perspective, and to constantly be throwing yourself into something reminds the reader that they're listening to a person rather than just a fountain of ideas, I would say in general, okay? So you got a clear thesis, you got a clear hook. So I would say that, you know, several months ago there was there were several students that harassed an office building, and they were unable to be identified because they were not wearing school uniforms of the local school. I would say my thesis on this, I don't want it to just be one of these perspectives. I'm totally lost behind the text. Can I go over here? Yeah, I'm going to go over here. The thesis here, I would say, okay. Schools should require students to wear uniforms. Now notice that I just flat out said my perspective. I didn't have a reason, but I took a side of the argument here. You want to take a side. You don't want it to just be loose and kind of acknowledging both sides throughout the whole thing. You want to be firm on your side. Now, you do need to acknowledge the opposite, which we'll get to that in a sec. But you have to be firm on what you believe here. So students or schools should require students to wear uniforms as a matter of, let's see. I would say something like maybe to promote social cohesion between the students and the local community is probably what I want to say. Social cohesion, meaning that they're all in it together. They all look very similar, so there's not a lot of difference that you can tell from people of what they're wearing. And that also throws in social cohesion in the community. They're students. It's clear when they're walking around from these uniforms. So socially, it's you know who you're talking to. This is a student that goes to PS 67 down the street or something like that. So yeah, my thesis would be students should be required to wear uniforms because it improves social cohesion between the students and the local community. I suppose that one would consider alternative viewpoints, but highlight their flaws. Slayer Darth, yes. Yes, yes, yes. Yeah, for Slayer Darth, here's a very important part of this. So we start with a perspective. We talk about social cohesion in the perspective of I'm sorry, this is going to be our first paragraph. Uniforms erasing social class markers. That is a way to increase social cohesion. Kids don't feel separated because there's the kids that have really expensive clothing and the Gucci belts and the Prada shoes and things like. I don't know if Prada makes shoes. I've never owned anything by Gucci or Prada. And once you get to your against, there's a very specific way you want to acknowledge it. Because the way to build credibility as someone who argues is to not just neglect that there's another side to the issue. You need to address that, and then you need to crush it, okay? It's called a concession and refutation, okay? You want to have this structure in your essay. A concession and refutation, okay? A concession is when you concede something, which is, okay, yes, it's true that by making students wear uniforms, we're depriving them of the ability to express themselves through their clothing, right? I'm conceding that's the other side. But then you refute that. And you somehow, it's like you're setting yourself up to just slam the volleyball down on their side, saying, yes, it's true, but here's why that perspective is wrong. Here's why that perspective may be right, but it's not important, or there are things that are far more important. So yes, students are able to express themselves with their own clothing, but the benefits of self-expression are far outweighed by the costs of students self-identifying as members of certain social economic classes compared to other students. Something like that, where you're saying that, okay, yes, it's true, but it's not as important as this other thing, okay? You want to make sure that you have this in your against paragraph. And you might have a couple paragraphs, or not a couple paragraphs, but it might be that you have, only one perspective that's for, and then two that are against. And if that's the case, you probably want to start with your for paragraph. You want to come out of the gate hot and start with, here's what I think. You don't need to say perspective one. Like, you don't need to say, actually, according to perspective one. You might want to say, some people think that freedom of clothing allows students to express themselves. Like, you can acknowledge it like that. So then they say, okay, yes, they are acknowledging the perspective one. That's in there. That's a check. And then you want to talk about, is that right or is that wrong? So definitely you want your first body paragraph to be for the argument you're making. And then it might be that the other two perspectives are against paragraphs. And if that's the case, be ready to have very good refutations for both of them. Say, okay, some people think this, however, this, and this, okay? Here's why they're wrong in all these different situations. And then your last paragraph is, another thing that other people say is this, but they're wrong because this, and this, all right? And then hopefully you have time for a conclusion. If not, you could make your conclusion tie up with the bottom of the third body paragraph if you don't have time. But hopefully you can get to your conclusion. Now remember, your conclusion should not just be a rehashing of your introduction, because it's like, then it's not really that important. You want to add a little bit more. You want to leave them with something to think about. So your conclusion might be something like, let's see. It usually is a call to action. So yes, you have this perspective that you've expounded upon. But like, the question is, so what? So this should be conclusion. What do we do with this information? All right, students should wear uniforms. What should we do with this information? It might be that, we should reach out to our lawmakers and beg, or not beg them, but entreat them to make public schools uniformed, make uniforms in public schools mandatory or something like that. Because of the reasons that we spoke about or that we talked about, this should be a very strong. There's a very strong case to be made that uniforms should be made. I can't speak right now. Made mandatory in our public schools, and our government should be. And we should contact our local congressman to try to get this legislation passed. Okay, something like that. You don't want to just leave them off with like, there's nowhere to go from here. This is like a jumping off point. All right, it is where you want to take this information, because information by itself, your perspective on something, is interesting and it's great, but it's even better and more powerful if you give the reader a direction to go when they're done reading this. Okay, so in short, introduction. Make a little hook here, and then make sure that your perspective on this is very, very clear, which side of the argument you come down on, okay? And have a reason that's not just a perspective here that you just rewrite. Try to make it a reason that's in your own words, It might be an interesting, nuanced perspective here that has something to do with these perspectives, but it's a little bit different because of you, okay? Each body paragraph should reference these perspectives, not by calling them 1, 2, and 3, but by mentioning the things that they say. And you want to make sure that your first body paragraph is for the argument that you're making, okay? When you get to an against paragraph, make sure to set it up like concession or refutation, okay? The more that you lean into concession, the more credible of a writer you are, okay? So you don't just say that, some people think that uniforms let kids express their, identities or something. But here's the thing. You should give that a little bit more air. You should say, people argue that, a student's development is very important, and choosing clothing to wear can let you make yourself a certain style. Like, you really want to say, yes, there's something to that side, but then you crush it, okay, with your refutation. All right, finish your last body paragraph and conclude with, you don't really want to say exactly your thesis again, but you want to make it clear what side you're on again, and then you want your call to action, okay? What should we do with this information in terms of the first perspective? Slayer Darth, yes, in terms of the first perspective. You mean your conclusion, or what exactly do you mean? This is a lot of stuff. I am going to... Ivanikar, hope you're still watching. Hopefully this helps. I would say one thing that would help a lot is go online. They have a lot of sample graded ACT essays. So you can see a prompt and then see what like a 9 is, an 8, a 7. You can see what a bunch of different scores are and what people did and what they forgot to do. It'll show you the rubric that they used to judge this. But yes, I'm glad this is helpful. Yes, good, 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 good. You could, for instance, mention as a counter-argument that by wearing a school uniform, you are subscribing to that school's values and others, although you may not necessarily agree with them. Values and ethos, although you may not necessarily agree with them. Yes, yes, you could, exactly. So I see. So you might give them another reason why your argument is bad. Yeah, and the more good reasons you bring in, the better, right? Don't just hinge your essay on these perspectives. One of these perspectives might just be in the middle of one of your body paragraphs. It might not be what the whole body paragraph is about. You might have a body paragraph that's a reason that you created, and then in the middle of that body paragraph, you mention one of these perspectives, and it either supports your argument or it goes against your argument, in which case you have to refute it. But yes, you just need to make sure that these are included somewhere and that you break them apart, say if they're good or bad perspectives, and make sure that you explain if they back you up or if they, contradict what you're trying to say. All right, we're going to move on here. I think we had another math question on the Discord. Oh, man, okay. Gotta get rid of all this stuff. So much stuff. Who here is taking the ACT tomorrow? I am curious. I know someone said that. Was it L. Wayne that's taking the ACT tomorrow? Me. Oh, good. We got the two big ones. Good evening. The first draft I need to redo it. Could you please go over and explain it to me what I did wrong? I sent it on Discord. Ace chess. Normally the answer to that would be yes. Unfortunately, there is an ACT tomorrow, and we're doing a cram session for only ACT things. So we will be on back again on Tuesday of next week. I don't know when your draft is due, but right now we have to do ACT stuff because that is tomorrow. Here we go. Where's my other? Okay. Slayer Darth will never take the ACT. Slayer Darth, what country are you in? Are you in the UK? Are you in the Philippines? Ace Chess, we'll try to respond to it on Discord this weekend, okay? We won't be able to do it on the stream, but we'll send you something on Discord. Hopefully we can help you out on there. So we're going to go to... Oh, my gosh. Oh, now it's getting dirtier. Jeez. This board is so dirty. Okay. Going back to Discord. Let's see what we got. L. Wayne, or L. Juan, number 36. Oh, good night, Ace Chess. Thank you for watching. UK. I knew it was the UK. Or maybe you said that in a previous stream and I just kind of logged that in. Okay, so pentagons have 5 diagonals as illustrated below. Okay. Good, a little 5-pointed star. How many diagonals does the octagon below have? Let's see if I can make this. Okay. Yes. There is a very fun way to answer this. Jutman. Yeah, Levi and I both, that's where we met. Okay, so here's an octagon. And the question is, how many diagonals? All right, I'm going to show you the hard way. I'm going to show you the easy way. So the hard way is to draw in all of the diagonals. As long as you keep your lines clean and separate from each other, you can do it. But it just it's going to be a little messy, okay? So pick a vertex, like this one right here. This one is already connected to these two, so there are not going to be diagonals connecting them, but it's going to have to connect to every single other one. So we have 1, 2, 3, 4, and 5, all right? 5 diagonals coming from that vertex. That vertex is now out of the running. So we're going to move on to the other vertices, but they're already connected to that one, so we never have to count that one again. All right, let's go to this one here. It's already connected to that and that because it's the sides. So we have, I'm going to use a different color actually. This might make things a little easier. Okay. We have 1, 2, 3, 4, 5. All right, there is another 5. All right, you go to this one. Here's where we start seeing some overlap. We already have connected to this right here, so we're not going to connect to that. We have 1, 2, 3, 4. Look at that. We're no longer counting in 5s. All right? This one is already connected to 2 that we've already done. So we've already connected it to that one and that one. So we have 1, 2, 3. This one here, we already have that, we already have that, we already have that. So we just have 1, 2. And then this last one is only, no, I think we have, let's see, 1, 2, 3, 4. So we've connected to that one, that one, that one, that one, not that one. So that's 1. And then this one has been connected to all of them. Okay? So we add these up. We got 10, 14, 17, 18, 19, 20. There are 20 diagonals. Okay? If you can keep your lines nice and clean, keep track of everything, don't just put all the lines you can, then count them. That's impossible. You've got to take it step by step, okay? You'll get 20. Now, there's a different thing you can do here, which is super fun. Okay, here's what you can do. What you're trying to figure out is how many lines there are that connect 2 points, okay? A pentagon has 5 points, and if you choose any 2 points, there is a line between them. The line might not be a diagonal, it might be a side length. We'll address that, okay? But if I pick this point and this point, there's a diagonal between there. If I pick this point and this point, there's a side length between there, okay? We're putting these 5 points into groupings of 2, okay? And if you know combinations and permutations, you know that what this is a combination, all right? This is a combination. We have 5 things to choose from. We're putting it into groups of 2. 5 choose 2. This is on your calculator. You don't have to know how to do this, but it's on your calculator under the probability menu, okay? You definitely want to look at that, all right? And this is going to be 5 factorial over 2 factorial times 3 factorial, which is going to be 5 times 4 over 2, which is going to be 10. There are 10 connecting lines on this pentagon, but we have to discount the side lengths because the side lengths are not diagonals. There are 5 sides we have to take away, leaving us with 5 diagonals, okay? Now, knowing that, we can apply the same logic to this octagon because there are 8 vertices and there's a line connecting every 2. So let's figure out how many groupings of 2 there are. So it's going to be 8 choose 2, and that's going to give us 8 factorial over 6 factorial times 2 factorial, which is going to be 8 times 7 over 2, which is going to be 4. This is going to be 8 over 2 is 4, which is going to be 28. All right, there's 28 lines, but we have to forget all of the side lengths, and there are 8 side lengths. Take away 8 side lengths, and you have 20 connections here between 2 dots that don't include the sides, which means that they're the diagonals. All right, That is the quicker way to do it, rather than drawing the side lengths. But if you don't know this, draw your sides, be very careful. Be very methodical, count your sides as you're drawing them, you know, in some kind of a step-by-step way. I like this one better too, yeah. Although I do like drawing lines. That's really, really fun for me. I do like that because it's faster. So you can do some pretty quick calculations if you've got a 27-sided shape. 27 choose 2 minus 27. You'll get it right there. Let's see, are there any other questions? No other questions right now. Where did the 6 factorial come from? Good question, Jutman. We're talking about over here. Okay, so there are formulas for, also speaking of, can you do number of permutations that we form from people? Yes, we can talk about that. All right, let's talk about permutations and combinations in general. There is a formula for both of these things, so let me get rid of this. And the formulas you do not need to know, because they're programmed on your calculator as long as you have a calculator that has them on there. I guess that's kind of, that makes sense. There's NCR and NPR. All right, NCR is n factorial over r factorial times n minus r factorial. NPR is n factorial over n minus r factorial. You don't have the r factorial in there as well, okay? So where this 6 factorial came from, that's the n minus r. That's the 8 minus 2 is 6, and then we multiply it by r factorial. I got the right answer by guessing, but I thought I'd maybe draw it out kind of. Yes, so let's talk about people, and then we can just talk about, you know, permutations and combinations in general. So people. People has 6 letters. I feel like I should say people have 6 letters, because it's people's normally plural. But it's people. The word has 6 letters, okay? How many different arrangements can you do? You've got 6 objects here, and you're going to rearrange them. But you're going to rearrange them back into groupings of 6, okay? The fact that order matters tells you want to use permutations. With combinations, order does not matter. With permutations, order matters. Order meaning you put them in different orders, you get different possibilities. So for instance, if you have like A and B, and then you have B and A, that is the same grouping of 2 letters. Low disk space. Interesting. Okay, hold on. Not going to manage that right now. These are the same grouping. These are the same combination. So you wouldn't want to double count them if you're doing combinations. If you're doing permutations, these count as 2 separate options. That's what order matters means. Let's go back to people for a second. We're putting them in different orders, which means we're doing permutations. We're taking 6 letters and we're rearranging them, but using all of them, okay? So the first thing you want to think about is we're doing 6 permute 6. Let me get rid of this for a sec. Okay. 6 permute 6. All right, which, if we use our formula, but again, it's on your calculator, is going to be 6 factorial over 6 minus 6 factorial. All right, which is 6 minus 6 is 0. 0 factorial is 1. Okay, it's a weird little quirk of math. 6 factorial over 0 factorial is 1. So you think you're done, right? 6 factorial. That's how many options there are, but there are not. And here's why. We have a couple of identical letters. P and P, they're the same letter. E and E are the same letter. So you have a couple different permutations here, which to the untrained eye would look identical because they are. There's nothing separating this E from this E. So you might have it where you have, like, let's say E-L-E, O-P, what's the other thing that we have? P-E-O-P-L-E. Oh, there's another P, okay? Yeah, you might have it, this is one of your arrangements, but then you might switch these 2 E's. And then you have a different arrangement that looks like this. Guess what? It's not another arrangement, it's the same exact arrangement. You have to get rid of those. Otherwise, you're double counting a ton of arrangements. And so here's how you do it. After you figure out the total number of possibilities, you have to account for your duplicates. So here's what you do. You divide by, if there's an object that you have 2 of, right now we have 2 P's. You put 2 factorial on the bottom. Whatever the number is of the identical objects, you write that number, then factorial. But that's not the only thing, because we also have 2 E's. So there's another 2 factorial we put on the bottom, okay? So we get 6 factorial over 2 factorial is just 2 times 1, which is 2. So 2 times 2 is 4, all right? So 6 factorial over 4, whatever that ends up being, use your calculator. There's going to be a little bit of a simplification here because the 4's are going to cancel out. So the 4's cancel out, and the 1 doesn't matter. So the 4s are gone. Here we go. I should probably keep them there, just cross them out. Here we go. So you have 6 times 5, which is 30, times 3 times 2, which is 6, so you get 180. That's how many different permutations there are going to be. They had 2 times 2 on the bottom. Exactly, Owen. Right there. Okay, so the answer, they didn't actually, simplify everything. They kept it in terms of factorial. But yes, those 2's on the bottom account for the fact that you have 2 P's and 2 E's, and you cannot double count them because they're identical to each other. Oh, I'm blind. No, you're not blind. You can see. And what you see is so beautiful that your eyes become blinded. That's probably what happened, is you were just blinded by the beauty. Of just things in general, not necessarily me. I wouldn't describe myself as beautiful. I'd put me at a firm 7. All right. Let's watch this. Okay. All right, more questions, please. I can go over all sorts of stuff. I can go over some rules of grammar. Those are pretty high gain topics. Once you understand them, your English score goes up a lot. I can go over some more math formulas. We can talk about systems of equations. We could talk about quadratics. We could talk about matrices. We could talk about the science section. What do you think will be on there tomorrow? I don't know. I mean, if you've ever taken a practice test, there's a bunch of concepts that always show up, like commas will always be tested because that's really important. But on math, for instance, matrices sometimes come up, sometimes they don't. That's the thing, is that if you knew what was going to be on it, it would not be. Over want to use dashes. Chapman, absolutely. We can absolutely talk about dashes. I am so glad you brought that up because I was hoping someone would. Because I have this weird rule with Levi where he's like, never talk about dashes unless someone asks for them. And I'm like, why? I like them. And he said, no. He never said that. I'm making this up. But I'll talk about dashes, sure. Sure. Okay. I'm going to get a different rag here. Just ragging it here. Matrices. I just use my calc for them. I have taken like 20 practice tests. That sounds like you're having a good time. Is your score going up? Do you see it going up? Just taking them over and over, even different ones, as long as you understand the things you're getting wrong and then you're learning from that and not making the same mistakes, your score is going to go up. So hopefully you're seeing some improvement. All right, talking about dashes here. Dashes. I've literally never gotten a score that's not 35. Yeah, I got a 36 the last 2 times, just freaking out. Don't freak. Are you kidding? Don't freak out. You're fine. A 36 the last 2 times? Some kids would die for that. Except then they wouldn't get it because they'd be dead. But 33 factorial, not 35. 33 factorial is huge. You can't do that. Okay. Here we go. Dashes are used in a similar way to commas. Separate non-essential information. Okay? Think about this one. Sometimes it's essential, though. Separate information. De-emphasize information, emphasize information. Which one do they do? Well, I'll talk about one way that you see dashes used a lot, okay? Which is the interrupting element situation. So a lot of times you have these things. The fancy name is appositives. They're information that come in the middle of the sentence and they interrupt the flow of it, and then the sentence continues afterward. Okay, so I could say something like this. Let's see. My friend Levi, who is absent today, is having fun. Okay? The interrupting element in the sentence is right in the middle. Who is absent today, okay? The reason why we know it's interrupting, can you help me with this problem? Sky Reaper, yes, what's the problem? You can put it on the Discord or on the chat. Who is absent today is removable. We could get rid of it. We'd have my friend Levi is having fun. That is the original independent clause. And then this thing just reared its ugly head and it just stops the flow of the sentence, inserts its own fun information, and then resumes the flow of the sentence. When you see that, you typically use commas on both sides. One to tell the reader, we're taking a right turn for a while. Here we've gone right, great. And now we're going back on track, okay? You can also use dashes in this context, okay? You could have put dashes here. So we could say, who is absent, dash is having fun. Here's what they're going to try to get you with. If you have an interrupting element that starts with a comma, you must end that with a comma. You cannot end it with a dash. If you have it starting with a dash, you have to end it with a dash. It's basically, when they set up a pattern for you, they want you to continue the pattern. So you can either do dash and dash around an interrupting element, or comma and comma around an interrupting element. But you can't do some mix of both of them, okay? That is one of the ways that they use dashes. Another way of using dashes is to separate, what do they do? What do they do? Sometimes it's like at the end of a sentence to emphasize something, okay? I know that seems like it's the opposite of separate non-essential information. In this context, that's what they're doing, is they're separating non-essential information. And then they also can be used to emphasize something important. So yes, Jutman, that's right. Here's what it would look like in that case. So I finally got the score I wanted. An A, oh, that's a colon, sorry, hold on. An A plus. Okay? In this case, this dash would be used to emphasize an A plus. It's not non-essential, because if you take that out, we're missing some crucial information, which is what is the score that you wanted. Okay? So they also are used to emphasize. Here we go. When you see it in this context, it's very similar to a colon. A colon can also give you an explanation for something, or give an example of something. Colons aren't just used for lists, even though that's what they're used for a lot. They can also just explain something, right? What is the score that you wanted? It's an A+. So colon and a dash are very similar in that manner when they're used like this. The thing with a colon is that the thing before the colon must be an independent clause. You cannot end a phrase with a colon if it can't stand alone. So you can't say something like, my hobbies include, colon, volleyball, dancing, and whatever. Because my hobbies include cannot stand alone. So you cannot put a colon after that. Same thing with like, I eat a lot of foods like, colon, steak, fish, and chicken. You can't finish a sentence with like. You've got to see a period where the colon is, and that thing before it must be able to end with that period. And if it can, you can use the colon. They really don't test you on the uses of the colon. They test you on the rule that there must be an independent clause, which is a full sentence, before the colon. All right? You can have whatever you want afterward. All right. Sky Reaper, 212. We can talk about that math problem. Okay. I do like this problem a lot. Okay. A polynomial in X has m non-zero terms. Another polynomial in X has n non-zero terms. These polynomials are multiplied, and all like terms are combined. The resulting polynomial in X has a maximum of how many non-zero terms? Do they tell you that m is less than n, or that m is greater than n? Because I do remember doing this question, and I do think they give you a little inequality for what m and n are. M and m are. That's a bunch of weird sounds. So take a look, because that should be in there. Yes, they do. Yeah, that's what I thought. What is the inequality they give you? Ha ha. Yeah, you did. You know who didn't? Big Braid. That's right. M is less than n. All right. This is a question that's near the end of the math section, so it's pretty difficult. So let's start with some terminology. When they say a polynomial in X, what they mean is that's the variable, okay? You can have a polynomial where you have a bunch of z's in it, z squared plus 4z minus 2. In this case, the polynomial has X as its variable, okay? And when we have a bunch of letters, a bunch of variables in the question and in the answer, it is often a good strategy to put your own numbers in there. All right, so m is less than n, we know that. The first polynomial has m non-zero terms, okay? Let's pick a number for m that's super easy. Let's say that it's 2. And let's call n 3 for that matter. So every time we see m, we're going to start saying 2, and n is going to start being 3. All right, a polynomial in X has 2 non-zero terms. So let's come up with that polynomial. Let's say that it is x squared minus 3. All right, that's a polynomial right there because it has multiple terms. That's it, okay? Another polynomial in X has n non-zero terms. So here's the other one, and we're going to use 3 for that. So let's say that it's x to the 4th minus x cubed minus 2x. All right, there's another one. These polynomials are multiplied and all like terms are combined. So let's go ahead and do that. So we have x squared minus 3, and we're multiplying it by x to the 4th minus x cubed minus 2x. We multiply and all like terms are combined. We're going to have to do FOIL here, except it's a little more complicated than FOIL because there's 3 terms, not just 2 and 2. But it's the same principle. We're multiplying every possible pair from one set of parentheses with another value in the other set of parentheses. So let's start with the x squared. X squared times x to the 4th, x to the 6th. X squared minus x cubed is minus x to the 5th. X squared minus 2x is going to be minus 2x cubed. Then we have the 3, negative 3x to the 4th, negative 3x cubed, and then this would be positive 6x. And all like terms are combined. We have 2 like terms here. So we have x to the 6th minus x to the 5th minus 3x to the 4th. We combine these two, we have minus 5x to the 3rd, and then plus 6x. All right, good. We're going to keep going. The resulting polynomial has a maximum of how many non-zero terms? Well, we have 1, 2, 3, 4, 5 terms, all right? So we can eliminate some answers if they don't allow 5 as a possibility. So the first answer, A, is just the letter n. And n we chose was 3. So could it be possible that this answer has only a maximum of 3 terms? Obviously not, because we have more than that, all right? So A is out of there. With B, they have m plus n over 2. Using our numbers, that would be 2 plus 3, which is 5 over 2, which is going to be 5 halves, which is 2.5. That's weird. You can't have 2.5 terms. So that's out of there too. B is gone. C is m plus n. So that would be 2 plus 3, which is 5. All right, so C's in the running. M plus n. That's cool. All right, D, m times n over 2 would be 2 times 3, which is 6, over 2, which is 3 again. 3 terms is too small. We have 5 terms here, so that's wrong. And then E, how you do this? E is m times n. 2 times 3 is 6. Now 6 would be fine because it's bigger than 5. Okay, what tennis streams? We have a Discord link below. I don't know if you're on Discord. It's an app that you can download that lets you text members of a group. So join up on our Discord. It shouldn't take you that long. You'll see the instructions below. And you can send us a photo on that. Can I share a link with a photo? Yeah, you can send it on that. Okay, so E is m times n, which is 2 times 3, which is equal to 6. And that would also be cool. That'd be a maximum because 5 fits underneath that, okay? So it's either this one or this one. So once you've eliminated the other options, one thing you can do is change things around a little bit. Maybe choose a different number for m and n. But here's what's going on. Is there a way to get more than 5 terms? Was there a way to get 6 terms somehow? Why didn't we end up with 6 terms? We had 2 terms times 3 terms. So there were 6 different multiplications we had to do. But then we combined like terms, and 2 terms became 1 term. Is it possible that we could choose polynomials so that there'd be no like terms to combine? And the answer to that is yes. You can choose exponents so that you won't get any of the same exponents afterward, and you'll have no like terms to combine. And if that's the case, 2 terms times 3 terms will give you a total of 6 terms. And that is the most number of terms you could get. Until you start combining like terms, they'll get smaller from there. So the answer is going to be m times n. Let me know if that makes sense. I did not hear that, sorry. Sky Reaper. Does that make sense, Sky Reaper 212? Or are you too busy reaping the sky? I may have missed this, but why did you make two different polynomials with different powers? Highest degree, right? Sky Reaper. It was up to me. They didn't tell me to. They just told me that there were two polynomials with different degrees. Sorry, not different degrees. They said two polynomials with different non-zero terms, a different number of non-zero terms. So this has 2 terms and this has 3 terms. I just chose to have these particular terms be my terms. It doesn't matter what you choose. You want 3 terms and 2 terms if that's what you pick for m and n. So that's just what I made up. So as it turns out, it's not that it's 6 terms because it's x to the 6th. That's not why. Because I could have made different polynomials where, let's say I have a polynomial that's x to the 4th and a polynomial that's x squared, right? Then I get x to the 6th. All right. 1 times 1 would give you 1. So in fact, this would still work because there's no terms to combine. But there's not 6 terms here because it's only 1 term. So the fact that we have 6 terms is because we have 2 terms times 3 terms. We're doing all of these combinations. There are 6 multiplications we have to do to quote-unquote FOIL this quantity with that quantity, and that gives us 6 different things, which depending on the exponents that you pick, there might be some terms you can combine, there might be some terms that you can't combine. In this case, we had 2 that we could combine, so we ended up with 5 terms. But like I can show you a different polynomial set where there'd be no simplifications you can make. I'll do it over here. So let's say we have x to the 7th plus x to the 6th plus x to the 5th. We're going to multiply that by x plus 1. All right, so let's see. X to the 8th plus x to the 7th plus x to the 7th. Hold on. Let's make this squared. No, we're going to make this. We're going to make that to the 4th. Okay? So we got 3 terms and 2 terms. I'm going to do 6 different multiplications, and I'll do it in a way that there will be no like terms to combine at the end. All right? So the first one we're going to have is x to the 11th, because it's 7 times 4, plus x to the 7th. All right, then we have plus x to the 10th, plus x to the 6th. Then we have plus x to the 9th, plus x to the 5th. Right there, those are 6 terms, and there is no combining of like terms that I can get. So the maximum number of terms I could have gotten this is from 6. All right, Sky Reaper, does that make sense? Ah, very good. Very good. Yes. Let's see, has anyone posted on the Discord? Questions on the Discord. Looks like Jutman. Did Jutman? Oh, no, that wasn't Jutman that did that. So we have a tab on our Discord that's questions for stream, and that's where you should post your questions. Cool. All right. Eric TLT, or as I usually say, Trig Eric. How are you doing, Trig Eric? It's good to have you on the show, Eric. Trig Eric. He likes trigonometry. Great subject. I love it. I like this question. The thing that you want to keep from this question is when they give you variables in the question and variables in the answer, and it's not clear what they want you to do, put numbers in for those variables and carry it through and see what happens. That is the strategy. Oh. Trig Eric, I'm good. I'm in my element, as you can see. Erasing boards, talking in dialects that aren't mine. That's what I wanted to do with my life. Oh, yes. That's right. This board is quite dirty. Do you recommend downloading any programs on the T84 Plus G? Yes, I do. Yes, I do. There is one that I have that I could send to you. Ridvik, do you have the cable for your calculator? And have you downloaded the application on your computer? It's called TI Connect CE. You have to get that and be able to interface with your calculator through the cable. So do you have both of those things? So if you do not, then you need them. The only thing you can do is manually type in a program. Posted my question. Oh, very good. I will check this out. By the way, guys, we're streaming on YouTube, Facebook, and Twitch. So I just got a question on YouTube. That's why you guys didn't see it. They're asking about programs for the TI-84 Plus CE, which is a beautiful calculator. That's the calculator that I use. When I was growing up, calculators were not in color yet. When I was growing up, it wasn't that long ago. It seems so long ago. Yeah, I got a little sovereign cable. Awesome. All right, Ridvic, here's what we're going to do. When I'm done streaming tonight, I will email you. Can you possibly private message me on, so you're on YouTube right now. I think you can send a message through YouTube. Okay, let me look at this question. Private message me and I will email you the program. I accidentally reset it a little while, so I need to reinstall. Oh, okay. Let's see what we got here. All right. Oh, cool. Okay. So, what tennis streams? But anyway, yes, private message me and I can email you, because you don't need to put your email on this. I think that's probably not a good idea. And I can email you the program that I really recommend. It's got a ton of stuff on it. It's like a menu, and it's got 7 different things. You can go into distance, midpoint, slope, moon to moon to moon. The very beginning of this cram session, we talked about the essays. So you can either look at the beginning of that again and rewind, or you can just wait till this is over and then look at the beginning again. But we did talk in pretty good detail about what you want to do for the essay. Okay, so yeah, private message on Reddit. That sounds good. Here we go. We got a rocket. All right, I love rockets. Big fan of rockets. A rocket lifted off from a launch pad and traveled vertically 30 kilometers. So we're starting with that. Thank you so much. You got it. You got it. Then traveled 40 kilometers at 30 degrees from the vertical. Okay? I'm going to run out of space very soon. So 30 degrees from the vertical, and they have this in the picture, and that was 40 kilometers of distance. Awesome. Then traveled 100 kilometers at 45 degrees from the vertical. We have another vertical, and we have... So this right here is 45 degrees, even though it doesn't look like it, just trust me. And they traveled 100 kilometers. Okay. Only one that I've seen like this. Okay. At that point, the rocket was how many kilometers above the height of the launch pad? Oh, I love it. I love it. It's great. Here's where the rocket ended. Hopefully the rocket didn't end, but at that point in time it was there. And they're asking for what the height of this is. All right. Trig stuff. All right. This has 3 different segments of height. There's the segment of height that we get from our first segment of time, which is just the vertical launch. Then there is the segment of height we got from this 30-degree trajectory, and then this 45-degree trajectory. This one is by far the easiest. 30 kilometers vertical means 30 kilometers vertical. All right, that's this right here. Let's go to this. We're traveling at 30 degrees compared to the vertical. We travel 40 kilometers. You understand it now? Yes, you're going to have to do trig here, and you're going to find the y component of both of these right triangles. I don't know how you remember everything to do. I've done a lot of ACTs and SATs in my life, so I know the kinds of questions. But if you understand it now, it sounds like... Do you want me to continue with this? Does anybody want me to continue with this, or is everyone cool with that? Well, there's a couple things to talk about while I'm doing this that I think will... okay. So, this one right here, I'm going to redraw this triangle over here. So here's the vertical, here's this. We're traveling along this side here, 40 kilometers, and it is 30 degrees from the vertical. So this angle here is 30 degrees. The question we want to answer is, what is the height component of this triangle? All right, what is this y component? And this is a 30, 60, 90 triangle. You can use trig at this point, but there is a pattern that I think makes things a little bit easier. Let's use trig first, though. We're trying to figure out what y equals. The angle we're using is 30 degrees, and we have the hypotenuse. So the question is, we want to use sine, cosine, or tangent. Think about what you have. Do you have the opposite? No. Do you have the adjacent? Yes. Do you have the hypotenuse? Yes. Adjacent and hypotenuse is cosine. When I say having the adjacent, even though we don't know what y is yet, we're working with it. That's the important thing. We're working with the adjacent and the hypotenuse. So cosine is what we want. Cosine of 30 degrees is going to be y over 40. So to solve this thing for y, I multiply both sides by 40. So 40 times cosine of 30 is going to be y. All right. Cosine of 30 is root 3 over 2. Yes. Yeah. Yes. Okay. So this is 40 times root 3 over 2. That's a better one. So that's going to be 20 root 3. Here's what I want to say. There's a pattern for two different kinds of triangles that you should know because it'll make some calculations a little bit faster. And what they are, they're the special right triangles. They're the 45, 45, 90 triangle, and there's the 30, 60, 90 triangle. All right? So let's start off with the 45, 45, 90 triangle. So if we've got this would be an isosceles right triangle because if both these angles are the same, then both these side lengths are the same. Let's call them both 5, and let's see what happens with the hypotenuse. So to solve for the hypotenuse, we have to use Pythagorean Theorem. So we have 5 squared plus 5 squared is equal to c squared. So this is going to be 25 plus 25 is equal to c squared. So 50 is equal to c squared. So we have to take the square roots of both sides. The square root of 50 can be simplified as the square root of 25 times 2 is equal to c. And that's helpful because then we can simplify this radical even more and say this is 5 root 2 is equal to c. So let's go back up here. 5 root 2. The relationship between the legs of a 45, 45, 90 triangle and the hypotenuse is that the hypotenuse is just the leg times root 2. We have 5, 5 root 2. 5, 5 root 2. So in general, it's x, x, x root 2. Okay? That is the pattern that all 45, 45, 90 triangles are going to use. And that's really, really helpful because we have one right here. This triangle right here, I did not draw that well, but that's the 45-degree angle. So we're going to draw that over here. So this right here was 45, meaning that this would be 45. It does not look that great. I'm going to make this look a little bit more like a 45, 45, 90 triangle. There we go, 45. All right, and our hypotenuse was 100. We're looking for what our y value here is. All right, now this is a little weird because you expect the hypotenuse to be x root 2, and in this case there's no root 2 in it. We just have to deal with that. We have to set our hypotenuse equal to x root 2. These are going to be x. I have y already written there, but the pattern is x, x, x root 2. So if our hypotenuse is 100 is equal to x root 2, let's solve this thing for x, because then x is what the legs are. We have to divide both things by root 2. We're going to get x is equal to 100 over root 2. Now it's not cool to leave a square root in the denominator, so I have to get it out. I have to rationalize it, and the way that I do that is I multiply by root 2 over root 2. So 100 times root 2 for root 2 times root 2. All right? This gets rid of the square root from the bottom because this is going to give us 100 root 2 over 2. That's a question mark. Over 2. 100 over 2 is 50, so this is 50 root 2. So this last segment here is 50 root 2. So the answers are probably, they might be in radical form, they might be in decimal form, but these are your 3 y lengths, and so you just add them up and you'll get the total height. If our legs were 50 root 2, let's see if that makes sense with our pattern. Our pattern is x, x, and then x times root 2. So let's take 50 root 2 and multiply it by root 2 to get what our hypotenuse is. 50 times 2 is equal to 100. All right, so that makes sense. So that's the 45, 45, 90 triangle. Now we're going to talk about the 30, 60, 90 triangle. All right. Do you need to memorize these? No, you don't have to. Because as long as you have a calculator that does trig, you can always just say, hey, calculator, what's the sine of 45? Or what's the cosine of 45? And that's fine. But the secret to getting... Next, do you think they will make us do some Punnett squares again for the sine section? I remember with Mendel's laws and gametes. They might. It pops up every now and then where you have to know a little bit about genetics. The sine section occasionally has some previous science knowledge questions in them. I get confused on cross multiplying. I don't know when to multiply across or multiply top to top, bottom to top. Air TLT, that's a good question. What tennis streams? I have no idea. I don't know like the probability of getting a genetics passage, but would you like me to go over the Punnett squares? Because we can talk about that as well. Let's get rid of this here. Okay. Here we go. Yes, please. Oh, man, absolutely. Okay. So real quick, I'm going to end with the 30, 60, 90 triangle pattern. Let's get rid of this too. All right, so we also have to talk about cross-multiplying versus multiplying top to top, bottom to bottom. And there's also a question in the Discord. Let me put everything in order. So we have, Punnett Squares. Please go over Punnett Squares. All right, Rithvik G from YouTube. Rithvik G also says Punnett Squares. All right, Punnett Squares. We have multiplying. We also have Jutman. Let's get rid of this. All right, that's what we're going to talk about for right now. Okay, for those of you interested, the 30, 60, 90 pattern looks like this. The side length that's opposite, I mixed these up, hold on. The bigger angle is 60 and the smaller angle is 30. This is 60, that is 30. The side length that is opposite 30 degrees, which is the smallest side, because remember the smallest angle is opposite the smallest side, the largest angle is opposite the largest side. That's the one that we call x. The one that is the hypotenuse will be twice that. The one that is opposite 60 will be x root 3. All right? So if you had a 60 here and a 30 here, and let's say the hypotenuse was 20. The 30 side is going to be half of that. It's going to be 10. This is going to be 10 root 3. All right. All right, so we're talking about Punnett squares and genetics and all that stuff. Very good. Very good. Do like genetics a lot. It's fun. It's flirty. It's free. You can take it home. You can put it in your pocket, in your back pocket. Take it out. Mendel's law especially. Okay. Here's what happens. In your genetics, you have 2 copies of every gene. One from your mom, one from your dad. Okay? We're going to use the example of eye color. We're going to make this very simple. This is not really how it works, but this is just a simplification. Let's say there's only 2 kinds of eyes. There's brown eyes, and there's blue eyes. All right? Brown eyes. The instructions for brown eyes is a large B. The instructions for blue eyes is a small b. These are called alleles, and they code for the genetic code that gives you blue eyes. All right, we simplified and just called them letters, okay? So if you have a big B, you're going to have brown eyes. If you have a little b, you're going to have blue eyes. But it's not that simple because you're going to have 2 letters in your genetic code, okay? Here are the options. You might have big B, you might have big B, and you might have little b. All right, you get 2 copies of everything. And there's a difference between these besides the fact that one's brown and one's blue. You see a lot more people that have brown eyes than blue eyes because brown eyes are dominant. If you have a set of instructions for brown eyes, you're going to have them, brown eyes, regardless of what your other instructions say. This right here is recessive. They're a weaker gene. They will not be expressed if there's a dominant gene there. So big B, that's going to be brown eyes. You have a set of 2 big B's, and either one of them would give you brown eyes. Big B, little b is also going to be brown eyes. The only way you end up with blue eyes is if you have little b. All right? They will not be overpowered by the big B there. Okay? So Punnett squares, I hope they would not give us sex-linked trait ones. That gets pretty complicated. Yes, I would hope that they don't give you that either. Punnett squares are a tool to let you figure out the chances of certain offspring traits judging by the parents' traits, okay? So the classic example is that you have 2 brown-eyed parents, but both of them have the blue-eyed gene, they just don't know it, all right? They both have the recessive B in there. So one side will be the mom, one side will be the dad, all right? Where it doesn't matter which side you put on which. We have big B, all right? Little b on both sides. In every square, you combine the 2 that are next to or above that square. So this is big B, this is big B, this is big B, and this is little b. These are the 4 different possibilities of what the children or what an offspring could come out as, okay? Now, when you create what's called a gamete, and a gamete is the scientific term for a sex cell. So for men it's sperm, for women it's eggs. When you create a gamete, your genetics basically split in half. If they didn't, you'd get a kid with double the genetics that they're supposed to have. Okay? That's not cool. You already have 2 copies of everything. So imagine your kid having 4 copies of everything. The kid would explode. Okay? So what your body does is a process called meiosis, where it creates sex cells by taking its genetic code and basically splitting everything in half. So you only have 1 copy of everything. It's a very random way to do it. So you create all sorts of different random possibilities, which is why you're never going to have the same kid twice, unless you get twins, but that's a different story. So that's why you're only going to get 1 letter from your mom and 1 from your dad. You're not going to get both of them. Okay? So in this offspring's probability, there's a 1/4 chance they're going to end up with blue eyes, because 1 out of these 4 boxes is little b. There is a 3/4 chance that they're going to have brown eyes, because 3 boxes out of these 4 are brown eyes. Okay? Some other words you have to know. When the letters are the same, we call that being homozygous. Homo meaning same, zygous referring to the zygote, I guess, which is, you know, the fertilized egg. When the letters are different, we call that being heterozygous. Sometimes they use those terms and they expect you to know them. Homozygous are the same letters, heterozygous are not the same letters. The other thing you might need to know. Well, let's just do one more option. Let's say that you had, you had a blue-eyed parent. So you have a homozygous blue-eyed parent and you have a heterozygous brown-eyed parent. What you're going to get here, let's see, so big B, okay, and then this is going to be little b. You're going to have a half chance that the kid will have blue eyes and a half chance the kid's going to have brown eyes. What you're not going to get is a kid that has homozygous brown eyes. That's not going to happen. There's no way you can get a big B from one of these parents. They only have little b's to give. So you're going to get at least 1 little b, and then there's a half chance you'll get a big B and a half chance you'll get a little b from the other parent. Yes, those are your options. One thing that they do is they have multiple traits happening at the same time. So they might have like coat color for a dog and like teeth length or something like that. And what you have to do sometimes is analyze which letters, which alleles refer to which traits. And of those alleles, what do the capital letters do? What do the lowercase letters do? Which one's dominant? Which one's recessive? You have to do a little bit of detective work to figure out exactly which letters apply to which traits, which can also be kind of a hard part there. All right, I think that that's probably all you need for genetics. Yeah, has a lot to do with probability. Draw your Punnett squares. Does that include Mendel's law? I'm not sure I know exactly. I might have just had that in there. What's Mendel's law? Let's see. Oh, okay. Yeah. So Mendel's law is during the formation of reproductive cells, which is gametes, genes separate, so you receive 1 from each parent. Okay, yeah, I mentioned that. Sky Reaper, physics. Yes, we'll throw that on there. All right, the next thing we have to talk about is multiplying. When you multiply across and when you multiply the top by the top and the bottom by the bottom. Okay. Good, I'm loving these questions, guys. You guys are doing great. I love questions. I could go a whole day without eating as long as there's questions. I convert the questions into nourishment, and then I excrete answers as the waste. This is what I usually do. You can ask my roommates about that. There's answers all over the place. They don't usually smell, though, so it's okay. Okay. You're great. Siddharth! Siddharth, you're here! We were just talking about you. No, we weren't. But if we were, it'd be only good things, Siddharth, because there are no bad things to say about you. Because I don't really know you that well. So maybe there are bad things, but I don't know what they are. So you're off the hook for now. Maybe not next time, though. There's always next time. Okay. So this question, we're talking about, this is Trig Eric wondering about cross-multiplying versus multiplying across, which is terribly similar sounding. I never really liked that. Never liked it. Everyone else liked it. I didn't like it. I don't know. I guess I was just a little bit of a rebel. That's why I just stick it to authority. That's not true at all, actually. In school, I was a huge suck-up. I think I got away with it. I don't know. I think kids were okay with it. We'll see. Okay. I'm guessing you've gotten, I think I got her. Okay. All right. So, Eric TLT. Cross-multiplying, we're going to start with that. Cross-multiplying is what you do when you are solving a proportion. All right? It's going to look something like this. All right? When you have a proportion, that's a different question. Don't you need props for that? I got a 37 before. What are you guys even talking about? Okay? You might have two triangles where they're similar triangles. So we're going to say that this is 4 and that's 7. And you got a bigger one where this is 15. And you're wondering what this is. If they're similar triangles, then the ratio between this side and this side will be the same as the ratio between this side and this side. That means you can do a proportion. You need props for that? Is that what you mean by proportion? Props? Maybe? I don't know. So you set the two ratios equal to each other, and then you solve for the missing side length. Make sure when you do that, though, that whatever the order is that you put these in, so like 4 to 7, that's the bottom by the left. You have to make sure that matches on the other side. So the bottom, 4 by 7, would be here. X is the same thing as 4. 15 is the same thing as 7. And once you do that, props is in for acting. Do you need props for that? Acting. Wait, did I say something about acting? I don't know. Anyway, I'm trying to be funny and clearly it's not working. I'm not sure where the acting, what is the act? I don't know, whatever. So now you cross multiply. When you have an equal sign in the middle, that's when you cross multiply. Okay? 4 times 15, 60. So you do this times that is equal to 7x. If anyone did not know how to do matrices, you can do it on your calculator, giving a tip. Yeah, look up exactly how the matrix menu works, because it takes a little while to get used to it. Don't just count on being able to figure it out while you're taking the test. You want to be very comfortable with your calculator. Get intimate with your calculator. You know, warm a bath, you put some candles on, and have some music going, and just you and your calculator, you know, explore each other. 60 equals 7x. Divide this by 7. X is equal to 60 over 7 because I'm lazy. All right? That's cross multiplying. Eric, you're back. Oh, Eric, we're talking about you. Hope I didn't miss much. Eric, we're talking about you, man. We're doing this for you. We're doing this for you. I don't want to have to. Okay. Eric, when you have an equal sign between two fractions, that's when you cross multiply. If you're multiplying two fractions together, so maybe you got 2/3. If you're multiplying two fractions together, that's when you do the top to the top, bottom by the bottom. Okay? So this is going to be 8 over 27. Okay? So multiplying fractions, top by top, bottom by bottom. If you set fractions equal to each other, as in a proportion, that's when you cross multiply. Okay? If you want more review on that, watch the section that you just missed because you were gone. I didn't even know you were gone. Where were you? You at dinner? I don't know what you're doing. Okay, good. All right, multiplying. Jutman's time. It's time for Jutman. Jutman, let's see what you got. Let's see what you got. Jutty Jutman. All right. What do we got here? What do we got? Can you go over when to use apostrophes? Oh, yes, I can. Okay. Good. That's a great thing. Apostrophes are great. Love apostrophes. Okay. Go. Yes. Yes. Good. Yes, more of this. It's kind of a dead space when we're erasing. I don't want to say too much because I want to be writing it while I'm doing it, but I got to erase. The guy's got to erase in this day and age, especially in this economy. Oil prices being what they are, what are you going to do? If you guys ever want to sound professional at like a meeting or in like a group project, you start off what you say with the clause. No, it's not even a clause. You just start off with the phrase, oil prices being what they are, and then you say your point, and you will win the argument. Doesn't matter what it's about. Oil prices being what they are. All right? Make a little mental note of that. That's dirty right there. All right, apostrophes. I'll keep that in mind. Good. I hope you do. Okay. How long is this stream going tonight? I have math subject. I don't really understand. This stream is going all the way. No, it's going to go to 10:30 Eastern time. So we have about an hour, okay? Apostrophes are used for two different things. Number one, they're used for contractions, which happen before labor. I'm kidding. No, it's a grammatical phrase. And number two, they're used for possession. By your question, Jutman, I'm guessing about how you know when to use them for possession, if it's apostrophe S. Solid structure for the essay. Ritvik, we did the essay in the beginning of the stream, so you can probably rewind, I think, or you can just watch us when it's over, and we talked all about the essay there. Okay, contractions are where you put words together. Okay, so this is like don't. Yes, Jutman, you want possession. Okay, cool. Here's how you figure it out, all right? There's a couple different possibilities. In most cases for possession, you add an apostrophe S. There's only one case where you add an apostrophe after the S. So here's how this shakes out. So let's say that you have, okay, Jutman's book. So this is the book that belongs to Jutman. The thing that's doing the possessing is Jutman, all right? If we were to remove the possession, we wouldn't say Jutman's, because Jutman's is plural. You're not plural. It's just Jutman who's owning the book. Okay? So if it is singular and it does not end with an S, you put an apostrophe S. All right? So singular, no S. What I mean by that is that there's no S originally. Jutman is the thing that we're talking about. You want to add an apostrophe S. All right? That's the first situation. That's a lot of situations right there. Okay? Now let's say it was singular, but it does end with an S. All right? A word like that could be bus. The word bus is singular, but it ends with an S. So let's say that we had, this would be something like this. The bus's engine. You can hear as I say it, we add an S. We don't just say the bus engine. We say it's the bus's engine. The fact that we add an S shows you what we do here. It's an apostrophe S. It is exactly the same situation as what we had before. So even if it ends with an S already, because it's singular, we add an apostrophe S. So in both these cases, it's the same thing so far. All right? Those are the two singular cases. In both singular cases, you just set an apostrophe S. You get into the weird stuff when you start having plural nouns. The thing that's doing the possessing is plural, okay? So I'm guessing, so contractions don't really matter for you, so I'm going to get rid of this to save me some space. Okay. Here we go. So this is singular possession, then we're going to have plural possession. Okay. Ew. So much ink. Okay. We're going to call that singular. Now we have a new arrow, which points us to plural possession. There are two different situations here, just like singular. One where the word already ends with an S, and one where the word does not. Okay? Like this. Let's just take the weird situation when it is a plural noun that does not end with an S. And what I mean by that is something like this. Children. Children is the plural of child, but it doesn't end with an S. So we want to say the children's room. You add an apostrophe S. All right? So far we have three different possibilities here, and they're all adding apostrophe S. Okay? Also the same thing with the men's room or something like that, or the men's quarters. I don't know. I'm going to meet you at the men's quarters. Sounds very gentlemanlike or something. Then there is the situation where you put the apostrophe after the S. All right? And here's what it is. If the word is plural and already ends with an S, because it's plural, you put an apostrophe after the S. All right? So, if I were to say something like, the 40, okay, here's one. The cat's, that would make it clear. Okay. A lot of cats' tails. It could just be one cat with multiple tails, but that's not what we are used to. So it's going to be a lot of cats' tails, meaning multiple cats. Who is doing the possessing? Is it cat or cats? because it's plural cats, it's the word cats, okay? In this case, even though we have the word Jutmans, the thing that's doing the possessing is just Jutman. But in this case, it's the word cats, which is plural. It's plural and it ends with an S, so we put an apostrophe afterward. All right? Oh, you use the word cats. I guess that's why I thought of it. Okay? So there's only one situation where you put an apostrophe after the S, which is it is a plural word that ends with an S already because of it being plural. Then you put an apostrophe after the S. In any other situation, you put an apostrophe S on the end of the word that you're using. Okay? So the teacher's lounge. Does the lounge belong to one teacher or multiple teachers? It belongs to multiple teachers. And so the word that's doing the possessing is teachers, which is plural, and it ends with an S because it's plural. We put an apostrophe after the S. Jutman, does this make a sense? I hope it does. Whom versus who? Oh man, you guys are throwing the classics at me right now. Okay. So we also have who versus whom. Yeah, good. I'm glad, Jutman. That is my purpose in my life. My purpose was just to explain apostrophes to you just now. And tomorrow I will be hit by a bus. That's me knocking on wood. I hope I don't get hit by a bus. I have so many more apostrophes to teach to kids. It would be a shame if it was my last apostrophe explanation. All right. So we're going to talk now about physics. Some things you need to know with physics that might show up on the ACT science section. How many kids do you tutor a day? Depends on the day. I mean, so yeah, my partner Levi and I, we do private tutoring over FaceTime and in person if you're in the New York area. But then we do this at night, and so we obviously see a lot more kids doing this. But there are days, especially Sundays. Sundays is a very popular day for tutoring, where I've had as many as, oh geez, I mean, they were really busy days. I probably had 8 kids on those days. The sessions can range from an hour to an hour and a half. Yeah, you can do that. But during the school year, kids are at school during the week, so you can only really get them in the late afternoon and early evening or on the weekends. So you kind of have the opposite of a normal person's schedule. Okay, physics time. Things that you need to know for physics. Well, there's a whole area of science that you need to know for the ACT. It's not a lot, because mostly the ACT science section is testing your ability to interpret data from tables and charts and things like that. And the overall strategy for the science section is not to read the passages first, because if you do, first off, they're boring as heck. You're not really going to get a lot of it, and it's going to waste a lot of time. So what you do is you go straight to the questions, and they're worded in a way that they guide you where to look in the passage for the answer. A lot of times they'll be like, according to figure 2, what temperature was it on October 8th? And it's like, okay, I'm not really sure what the passage is about, but I know how to go to figure 2. I know how to find a graph that has the temperature and October 8th, and then you can figure it out and you got the answer without even reading the passage, okay? Not all questions are like that, but a lot of them are. So go straight to the questions. Sometimes they'll use a vocab word that it's like, how they expect me to know that? And in which case, there will be a definition of it somewhere in the passage. So sometimes you do need to know what something means, and they know that, and there'll be a, how to find the arc in the circle. Okay, here we go. So the question is, should you read the passage of the SAT? Yes, you should, Eric TLT. Yeah, and in the SAT, you have time to read those passages. It's really the science section of the ACT that you want to go straight to the questions first. I wouldn't really recommend that for other sections of other tests, especially if you're going to take it very soon. You don't want to change up your strategy that much. So we're also going to talk about arc length. Okay, good questions. There's one other thing in the science section you have to look out for, which is the conflicting viewpoints section. The conflicting viewpoints section is in essence... Oh, we just got a subscription. Hold on. Well done, Jutman! Well done! Ha ha! The conflicting viewpoint section does not have tables or charts or graphs. It's just like an essay. It's got some description of a phenomenon and then a bunch of scientists that are arguing over why they think it's happening. It's their own, each of them has their own hypothesis. That one takes the longest to do because it involves the most reading. Therefore, when you get to it, skip it and leave it till the end. The science section is notoriously hard to finish, so you want to spend your time doing questions that don't take you that long to get as many right as possible. So leave that till the end. If you have time, you'll get to that and you do those questions. Otherwise, you don't know where it's going to be in the order of the passages. So just whenever you see it, push it off till the end. All right, so things that you need to know for the science section as an outside science knowledge. One of them is pH. The pH scale measures how acidic or basic something is. The pH scale goes from 0 to 14, with the middle being 7. Now 7 is neutral, neither an acid nor a base. I don't know why I drew these arrows to like imply that it continues, because it doesn't. It's from 0 to 14. From 0 to 7, we have acids. From 7 to 14, we have bases. The further away you are from the center, the more acidic or basic you are. So you're close to 0, you're unbelievably acidic. You can have two acids, 3 and 4. The one that's 3 is more acidic because it's closer to 0. Same thing with the bases. The closer you are to 14, the more basic you are. The way that I remember this, any alkaline body kills cancer. Alkaline body kills cancer. Interesting, maybe. The way that I remember this is that A comes before B in the alphabet. So the earlier numbers are acid, the later numbers are bases. Okay? Water is neutral. It's a very important thing. Water is neither an acid nor a base, it is neutral. That's the pH scale. Next thing you need to know is the temperature scale. In science, we use the Celsius scale. Unless you're using Kelvin, but usually it's Celsius. The thing you need to know for Celsius is that the scale, the important numbers, are 0 degrees and 100 degrees. In this case, the scale would continue. 0 degrees is freezing point of water, because water is very important, and 100 is boiling point. These are incredibly easy numbers to remember, which is why they made a system like this. Because why would we want to make something stupid where 32 degrees is the freezing point and 212 degrees is the boiling point? 212 is such a weird number. You know what else is a weird number? 5,280, which is the number of feet in a mile. Why? Where did that come from? I mean, I'm sure it's very easily look upable, but the sooner we get to the metric system, the better, okay? Those are some things you have to know. Physics-wise, the thing that they usually have you think about is kinetic energy and potential energy, okay? You don't need to know the formulas, but it is better if you are more familiar with them. Okay, I should probably write this out. So there is kinetic energy. Kinetic energy, do we need to convert between C and F? No, you don't. Don't worry. They'll never ask you that. The math that you need to do on the science section is very minimal, and you can also do a lot of estimation. The answers are always super far apart, so if you have like 498 times 17, do not be afraid to turn that into 500 times 20. All right? They don't need you to get an answer that's exactly right. You'll see how different the answers are number-wise. All right? So estimation is your friend because it's also very fast. You don't need to get a calculator. You don't get a calculator for the science section is another thing. Okay, kinetic energy. Kinetic means movement. This is the energy you have when you are moving. The equation for this is 1/2 mv squared. M is your mass, v is your velocity. The fact that you're squaring your velocity means that that's a lot more important than your mass. If you double your mass, great, you doubled your kinetic energy. If you double your velocity, you quadruple your kinetic energy. You get a lot more bang for your buck doing that, okay? The other kind of energy they're going to want you to know, and there's plenty more different kinds of energy, but the two that you often see, there's also gravitational potential energy. Now, potential energy is stored energy. It's somehow there's a way that you can store it and use it when you want. And in this case, gravitational potential energy, I'm going to make a little picture here. So we have a little ball that's moving at velocity v. So there, kinetic energy. With this one, this is due to objects being held at a height. If you are at a height, you can be dropped, and you will pick up speed because of gravity. What that means is there must be energy in you because of the height you're at, because where else would it be coming from if you can suddenly pick up speed? Energy does not come out of nowhere. It's stored in certain ways and it transfers other ways. So the fact that you're suddenly falling means that you had energy in you somehow, and we rationalize it by calling it gravitational potential energy. You can't find it inside the ball, but it's because of the situation it's in, it's there. And the equation for that is mass times gravity times height. Okay? Gravity is around 10. I don't think they really need you to know that. The important thing is, though, the heavier you are, the more potential energy you have, and the higher off the ground you are, the more potential energy you have. G is a constant in physics. It's 9.8. You generally don't need to remember that number. Where is Levi? Levi, unfortunately, is not here tonight because he had a little screw up on his schedule, and he did not realize we were doing a cram session. So he got the Bozo Award for tonight, unfortunately. No electricity knowledge needed before, right? No. Not really, no. One thing that's weird is that they use the letter I to represent current. V is voltage, which makes a lot of sense because it's V. R is resistance, but they use I for current. I don't know where that came from. What about springs? Sky Reaper, what about springs? You've been talking about springs this entire stream. Huh? You want to make some of it? Yeah, springs are another way to store energy. You do see springs sometimes. Do you think you'll have time to go over reading tips and strategies? Of course. Of course I will, Jutman. Do you think I'm some kind of a person who doesn't have time to go over reading tips and strategies? Is that what you think of me? Because if that is, then I'm doing something wrong, because I never want to give some of that impression. Okay? Let's talk about springs real quick, and then we'll conclude physics. Okay. There we go. Hey! Kevin Lart. Thank you for following. Your name reminds me of Paul Blart, Mall Cop. Just probably it's not a great movie to watch. It's very dumb. But his last name is Blart, and your last name is Lart, at least on Twitch. I don't know if that's really your last name. Probably isn't, because better to not just, I don't know, broadcast your identity on the internet. But if you are doing that, then, you know, all power to you, but be careful. Be careful, because some people just want to harvest your organs. The quickest way to do that is to use your full name on Twitch. I've seen it happen so many times. It's very sad. All right. That looks like Summit Yourself. Yeah, okay. All right, Eric. One sec. Oh, there. Okay. We have a sponsor, altaipsum.com. It's the website. Alta Ipsum in Latin means summit yourself, which means do the best you can. It is an application that you can download on your smartphone or your computer that lets you outsource your academic stress to the app that will then tell you what to do. So it's got a grade tracker, it's got goal setting, it's got an academic schedule planner. It's a lot of things that you normally do on an assignment notebook if they still give you those. But you basically don't have to worry anymore about, like, what do I have to do and where do I have to be. As long as you put it all in the app will give you reminders. If you want to do an essay that's due on Friday, it will automatically put in Monday night, write your first draft, Wednesday night, edit your draft, Friday, Thursday night, finishing touches. It'll do that automatically. Also, Nerdish, we're regularly broadcasting Tuesdays through Thursdays, 8 to 9:30 p.m. Eastern Standard Time, so you can put that in your schedule to remember to study for the ACT and SAT. And it's free for a month. It's free for a month. Give it a shot. If you don't like it, then just stop using it. But if you like it, maybe you want to keep using it. I don't know. I'm not you. All right, we're done with that. Very good. There is also elastic potential energy, and that's from a spring or an elastic thing. All right? When you compress a spring, you're putting energy into it, because when it uncompresses itself, it does that with a vengeance, okay? And usually they call that U. These formulas you don't really need to know, because they don't require you to know the formulas. You just need to understand what's going on. The tighter you compress a spring, the more energy is in it, okay? What these letters are, K is the spring constant, which is basically how strong the spring is. X is how far you're either pulling the spring away from its rest position or how much you're compressing it from its rest position. And in general, here's a big idea. Roller coaster. You're on a car. You're at the top. You're about to go down, okay? Maybe come back up a little bit. When you're at the top and you're not moving, all you have is potential energy. As you start moving down, you're picking up speed and you're also going down height-wise, which means there's a transfer of energy happening. You are losing your potential energy as you're gaining kinetic energy, all right? When you're at the bottom, so let's say that this is, ground level right here, and you're still on the roller coaster, you're right here, you have no potential energy because you're not at a height anymore. All of that energy you had has been transferred to kinetic energy. So this is the fastest you will be going. Can you explain F equals negative kx for springs? Yeah, Ritvik, it's not going to be on the ACT. You don't need to understand that formula. If you message me, because you're going to message me about the calculator program. I'll explain it to you. But understanding that formula is not important for the ACT or SAT. And so as when you're down here, this is the fastest you'll ever be going. It's the most kinetic energy you're going to have. As you move back up, you start losing kinetic energy and slowing down as you're gaining potential energy because of gravity, and then you can go down. Okay, cool. That's physics. The next question is who versus whom? Who versus whom? Okay. Both of these are wet. They're always wet. Let's get something dry. Okay. Here we go. Here we go. Very good. I am curious how you guys heard about us. Did you guys see us on Reddit, on Facebook? Did a friend tell you? What's the deal? Feel free to share. I will read it. I'll say it. It's always kind of fun when someone on a screen says something you just wrote. Or you can keep it secret. You can keep it safe. Reddit. Bar and Twitch. Oh, interesting. Jutman. Interesting. So you decided maybe there's something on Twitch for this. All right. And Sky Reaper went on Reddit. Yes, we do post on Reddit from time to time, especially during these cram sessions. Because that's when knowledge thing on Twitch. Oh, the Knowledge Fellowship, of course. The Fellowship of Knowledge. It's like the Fellowship of the Ring, except it's not that at all. It's the Fellowship of Knowledge. There's no ring. There's no Eye of Sauron, although there is a black hole picture. Finally, it looks like the Eye of Sauron. And here's something that I find insane. I read this article about the black hole picture. The telescope setup that they used is sensitive enough to count the dimples on a golf ball in Los Angeles from New York, which is like, what? All right, who versus whom? From Damien Explorers, as he's on there, he sent the link to the Knowledge Fellowship. Haha! You can have my brain, and my wisdom, and my intellect. It's like Fellowship of the Ring, but it's knowledge. If you guys haven't seen those movies, you really need to. Here's the difference between who and whom. Can you also list grammar rules we need to know? Okay, yeah. Okay. Let's talk about this for a sec. Simple sentence structure here. Every sentence needs a subject. The subject is the thing or person that is doing the action. In this case, it's I. There needs to be an action, a verb. In this case, it's through. The ball is what the verb is acting upon. It is called a direct object here. More generally, I'm just going to call it an object. It's receiving the action, okay? Now, let's say that I threw the ball at someone. All right? Let's say I threw him the ball. We don't know who him is, but whatever. I'm not throwing him. I'm throwing the ball at him. This word right here is also an object. It is an indirect object. So this right here is a direct object. This right here is an indirect object. But notice I used the word him. What I did not use was the word he. I threw he the ball. Because in this situation, we don't want to use he because he is a subject word. Him is the object word. When it's being used as the recipient of a verb, you want to use the object. If it's doing the verb, you want the subject. So similarly, I would not say her threw the ball. Because her is not whomst threwed ye balloid industrial cardboard. I haven't seen you I've never seen you before, but I love it. I think it was her. I think that's who it was. Her threw the ball is not right because her is an object word as well. You want the subject version, which is she. Okay, she threw the ball. This is all going to come together. I swear. I swear. Here's where things go. All right. So we have subjects and we have objects. Actions are done by subjects to objects. And we have words that have two different forms. All right? You've seen all these. You know how to use these. Here it is. When the word is being used as a subject, we use who. When the word is being used as an object, we use whom. I will give you examples. Don't worry. The way that I match this up, though, the em and whom is just like the em and him and the em and them. Okay? Examples, because obviously we need those. All right. Who is at the door? The whole strategy here is replacing the word with a different word and seeing which one you want to use. So you either want to replace these words with he or they. I'm sorry, hold on. You either want to replace these words with either he, they, or him, them, and see which ones sound better. So, would we say he is at the door, or would we say him is at the door? Obviously, we'd say he is at the door. This is a subject. That's what's called for in this part of the sentence. So we want to use who because who is used as a subject. Okay? Let's look at whom. All right? Oh, man, I got to get better at writing. Okay, we're going to... Okay, sorry. I call that the crying penguin. I'm going to give you guys who/whom did you vote for? A little point here. For is a preposition, and you don't normally want to use a preposition at the end of the sentence. You'd probably want to say something like, for who did you vote? But just, who must be two birds' hands worth one bush? I don't think you're comparing the birds to the bush. There's a bird inside the bush, a bush bird. And then you have two bush birds and there's one hand bird. And they're equivalent. Jutman, thank you. So whom shall I turn it to? Turn it into? Yes, Ritvik, that is correct. In this case, we're going to do our replacement, but it's still going to sound a little weird, but just bear with me for a sec. The verb here is vote. Who's doing the voting? Is it the who or whom, or is it the you? It's you. All right, that's the subject. If you rearrange this sentence, you have you did vote for whom. Okay? Would you want to say, so I'm going to sort of take this and put it over here. Would you want to say he, or would you want to say him? You voted for he, you voted for him. You'd want to say you vote for him. It's receiving the action. We want to use whom. Whom did you vote for? Okay? That is grammatically what it is. Now, when you're talking to your friends, I would recommend maybe not using whom if you want to keep them. Because whom is seen as kind of like, you know, whom. So be careful with your use of it. But you need to know it, because it's on the ACT and SAT. Indeedably. Industrial cardboard. What's going on? I like this. This is fun. Industrial cardboard, it's very strong cardboard there. Okay? Who asked about who versus whom? And does this make sense? So whom replaces him or them? Who replaces he or they? If you want to use she and her, you can use that as well. I just try to keep it easy. Yeah. So that is who versus whom. Very good. Very good. All right. Arc length. Or as sea lions say, arc length. Yes, it does. Thank you. Good. Good. Oh, we love this. This is our favorite. We don't want to ever stop doing this. No food, no bathroom breaks, no water. Stop breathing, just teach. Just objects and subjects. No breathing. Okay, good. What time are we at here? 10:03. Fantastic. It's just flying by. We love this. We are having the time of our lives right now. It's just us together, hanging out, talking about verbs. What else is there, you know? In this life, I don't know. I don't think it gets better than this. I've traveled across the world. I've looked for other things that might be better, and they're just not there. They're just not. He's going to explain it too, but this is what I think of it. How do you remember arc length formula? Oh, Rogard. Breathe, yes, nitrogen good for bones strong. Is that true? Is nitrogen good for bone strong? I went to school with bone strong, actually. Arc length time. Circle. Radius, 6. First thing you must know, how to calculate the circumference and area. If you don't know that, you've got some larger fish to fry. The arc length is a slightly smaller fish. You want to fry it later, but we're going to fry this right now. Circumference is 2 pi r, which in this case would be 2 times 6 times pi, 12 pi. Fantastic. Area is pi r squared. I remember it as the area is pi r squarea. Area, squarea, pi r squarea. Great. Which in this case would be 36 pi. Now let me throw a situation at you and see how you react. Okay? Here's our sector, right here. This thing right here, okay? How would you find this arc length right there? Okay? So we're going from A to B. How would you find that? Oh, Rogard, look at that. Well, you should be able to see that a right angle makes 1/4 of the circle. That's what this sector is. It's 1/4 of the circle. If it's 1/4 of the circle, this arc length here should be 1/4 of the overall circumference. Okay? So visually, that makes sense. So 1/4 of the overall circumference. We take this circumference, 12 pi, and multiply it by 1/4, we're going to get 3 pi. All right? The arc length is 3 pi. Yes, but I think they give you the formula. This is on the SAT. On the SAT, they give you the... Do they give you the formula? They don't do it on the ACT. On the SAT, I do not believe they give you the formula. Are there questions with radians or just degrees? There are questions with both. Good question, Ridvik G. There are questions with both, okay? And then also the area of this thing is going to be 1/4 of the overall area. So we take the overall area, multiply that by 1/4, and we get 9 pi, okay? This is not the formula, but I just want to show you the basic concept behind this, okay? Here's the basic concept. Whatever fraction your central angle is of the whole circle, whatever that fraction is, it'll be the same fraction that your arc length is over the whole circumference. And your sector area will be over the whole circle area. They're all ratios here. They're all the same ratio, okay? The general formula here, this is important. Angle over 360, assuming we're working with degrees, is equal to arc length over circumference. It is a ratio. You're finding it's a proportion. You're setting two ratios equal to each other. All right? Alternatively, you can also set this equal to sector area over circle area. All of these take the same form. That form is part over whole. Okay? So let's do a weird one. Let's do a weird one. I'm so bad at using space. It's just terrible. We're going to go up here. Circle has a radius of 8, and the sector is 32 degrees. All right? You know, this is a tiny circle. This is dumb. Let me clear up some space. Yeah. Yes. Clearing up some space. You know what? Okay. Well, everyone knows it's a cram session. I'm going to use that space too because I'm tall enough. Levi and I adjusted the board so we could use more space on the top. I'm going to rewrite this. I'm going to keep that at the bottom. That's important. Which trig identities do we need to know? Good question. Going to throw that on the queue. Okay. Go. You are the dancing queen. Young and sweet, only 17. Dancing queen, feel the heat of the Okay. Make sure I read tips the cue. Oh, I didn't do that. Sorry about that. Reading tips. All right, so radius is 8. Our sector is 32. First thing we're going to find is our arc length S. So angle over 360, 32 over 360, is going to be equal to our arc length, which we're calling S, over our circumference. Let's figure that out. Our circumference is 2 pi r. Our r is 8. So 2 pi r is going to be 2 times 8, which is 16 pi. Put this over 16 pi. This is our proportion. Then we just multiply. We just multiply, okay? One thing that I like to do is if a fraction is simplifiable, I want to simplify it first before I cross multiply and things get even messier. So 32 over 360, that is the same as 16 over 180. It's the same thing as 8 over 90, which is the same thing as 4 over 45. All right, it's easier. So this is going to be set equal to 4 over 45. Now we cross multiply. 45s is equal to 64 pi. Divide by 45. Divide by 45. S is equal to 64 pi over 45. The answer on your test will either be an exact form, well, it'll have a pi in it, or it'll be an approximate form, and they'll just multiply this in your calculator and get a decimal. One problem I see a lot of students doing is they forget the pi. They forget that pi is a number that's like around 3. They just lose it at somewhere, and they say, oh, it's 64 over 45. Yeah, but times 3.14. Like, that is a huge thing. Jutman, you can use that as long as your theta is in radians. It doesn't work for degrees, so if you know how to use that, go for it, be my guest. That's a very good formula, okay? The other thing here is finding the sector area. We're going to call that A. So the same start. I'm going to use 4 over 45 because I already know it's simplifiable. That's angle over 360 is equal to A over the area of the circle. Pi r squared. This is our r. You square it, you get 64 pi. Multiply here. 45a is equal to, what would that be? 240 plus 16, which is 256 pi. Divide by 45. Divide by 45. And you get your sector area is that over that. Okay? Yes. So these ratios, this is what I would use if I were you. Yes, you can solve them for the thing you're looking for. So like your arc length will be equal to angle over 360 times your circumference, which would be 2 pi r. And your area of the sector would be angle over 360 times pi r squared. But I like to keep it easy, keep it as a ratio. Okay, that's why I'm erasing these so quickly, because those are very easy to confuse, and I think these ratios make so much sense that the equation will stick in your head a little bit more. Okay, good. Arc length done. Just blasting through these. Just blasting. Grammar. We're going to do grammar. I don't care if you don't want to do grammar. It's what we're doing. It's what's for dinner. You're eating it. It's vegetables. They're good for you, even though you don't think they are. They're good for you. They have lots of, how you say, nutrients. Nutrients. Very, very good nutrients. You guys really want to know where Levi is? He's, every couple of weeks he has to regenerate in a nutrient-rich gel. Hey, Stream Elements, thank you. I mean, Sky Reaper, thank you for following. And Levi forgot to do that yesterday, and he got to his deadline where he just got to jump into his nutrient-rich gel, so he couldn't be on the stream tonight. So right now he is soaking in his nutrient-rich gel, and his cells are replenishing their energy. He's only part human. He's not a full human. I mean, he's part something else. So it's not that he's not a full human. He's a full being, but it's only part human. Mostly for the appearance, so he can get along in human society. Otherwise, he does lots of nutrient gel stuff. We're talking about grammar now. Okay. Give me 1 second. I'm going to get something to drink. I am back with something to drink. Toilet water. So good. You guys are just watching a stream of someone drinking water. I need this though. Trust me. All right. Oh, God. There we go. Jutman, I did not apply to MIT. All right, grammar. There's a lot of rules about grammar, but there's one thing in particular you guys need to know, okay? Independent clause. An independent clause is a relative of Santa Claus who don't need no help from no one. Yeah, okay. It's a complete sentence. That's what it is. Independent clause is a complete sentence. If it can stand alone, if it has a subject and a verb, you can write that down. It's got a subject and verb, and it is a complete idea. It can stand alone as a complete sentence, hence it's an independent clause, okay? If you have two independent clauses pushed up against each other, not separated correctly, you have what's called a run-on sentence. So, something like this. Levi is absent. He is soaking in nutrient-rich gel. Okay. This is a problem. We have a sentence that ends right here. We have another sentence right here. Okay, both of these can stand alone, and yet they are not alone. There's nothing separating them. There is a word for this. It's a compound word. This is called a run-on sentence. It's a run-on sentence, and it's not good. You can't have run-on sentences, okay? You need to separate them. And there's only a couple ways you can do it. A run-on sentence is not just a really long sentence. A run-on sentence is multiple sentences pushed together, not separated correctly. And there are 4 ways you can separate them, okay? Separating independent clauses. Okay, so let's be smart about this. Oh man, look at that 4-pack. There, good. Okay. First thing is a period. Just end your sentence and put a period there. That's what most sentences end with, and start your new sentence. You see that a lot. The next thing, comma fanboys. Let's talk about this because there's a lot to talk about. The fanboys are 7 words, for and nor, but or yet so. You got to know all of them. You got to know when it's a fanboys, all right? For and nor, but or yet so. The fanboys, along with a comma, as long as they're together, they can separate 2 sentences. If it's just a comma, it's wrong. If it's just a fanboys, it's wrong. They have to be together. Not only does a comma fanboys separate 2 independent clauses, but that is the only thing a comma fanboys does. These are 2 different things. You put them together, you create something new. It's a comma fanboys unit, and it's got one task in its life, to separate 2 sentences, okay? The only caveat to that is if you see comma and or comma or at the end of a list. Eggs, bread, and cheese, all right? That's a slightly different situation. Otherwise, if you see a comma but, it better be separated 2 sentences. If it's not, I will come over there and I will give that sentence a whooping, all right? Like it's never seen. That's comma fanboys. Third, a semicolon, all right? Semicolons are intimidating. They look fancy. They only do one thing. They only do one thing. They separate sentences. That's it. In effect, they are the same thing as a period. Functionally, they are identical. The only reason why a writer would choose a semicolon is it's a stylistic choice. It's less of a hard stop than a period. It's a little more of a bleeding into the next sentence kind of thing. But it only separates two independent clauses. If you see a semicolon, make sure the thing before it is a complete sentence. Make sure the thing after it is a complete sentence. If both of those are met, your semicolon is fine. If you can put a period where the semicolon is, it's fine. If there are two answers where the only difference is one's a semicolon and one's a period, they cannot both be right, so they must be wrong. There must be something wrong about them because they're identical. That's what they are. They're the same exact thing. That's a semicolon. Then you have colons. Colons do a number of things. We can use colons too, right? Ritvik, I just said the colons. You gotta let me try. Yeah, colons. Colons do a number of things. They introduce lists. They give examples of things. They explain things. But there's one thing in particular you have to remember. Before colon, you need to have an independent clause. You've got to have a sentence that ends with that colon. If what you have before the colon couldn't end as a sentence, you can't use it. The thing after the colon can be whatever you want it to be. It could be a single word. It can be a full sentence. Obviously it can because it's on this list of separating independent clauses, so it can be a full sentence. But the thing before the colon needs to be a full sentence, okay? Otherwise you can't use it. That is separating independent clauses. You're going to be surprised at how many independent clauses you're going to need to separate, right? They get into each other's business. That is a nice spot of grammar. I'm going to keep going. There's a ton of rules of grammar. If there are things in particular you want to know about, like commas or, redundancy, things like that, is 1020. I'm going to keep going here. Trig identities. That's what's next. For and nor, but or yet so. For and nor, but or yet so. For and, nor, but or. Yet so for and, nor, but or. Yet so for and, nor, but. Or, yet so. You gotta know them. You gotta say a lullaby to yourself each night. That's just for and, nor, but or, yet so, like 100 times. Alright? Then you will slowly become insane. And you will break. And then we will build you up stronger than you've ever been. You'll get a great score on the ACT. But then you'll be functionally useless as a citizen of society because you've devoted yourself to this test and only this test for the rest of your life. It's like the SpongeBob episode where he devotes himself to only fine dining and breathing. That's all he remembers. They threw out his name. That's all he knows. Fine dining and breathing. Whew. It was a workout, man. It's a very weird social situation because I'm literally in a basement. There's no one else here, and I'm talking to a screen. Oh man, I hope my mom's proud of me. Trig identities. There's two of them you gotta know. Well, first off, you gotta know SOHCAHTOA. You gotta know how to use SOHCAHTOA. That's important, okay? Actually, there's a couple things you might need to know besides that. First one is Pythagorean identity. Not Pythagorean theorem, Pythagorean identity. So it's like this. Sine squared x plus cosine squared x is equal to 1. Okay? So if you see something like this, these both have 5s in them. Take out the 5. Factor it out. See what's inside. Look at that. That looks like something. It looks like 1. That's what it is. All right? Pythagorean identity. That's it right there. Tangent is not just TOA. It's also sine theta over cosine theta. All right, you got to know that too, okay? The law of sines and the law of cosines occasionally come up. They typically give you the formula if you need to use it with a short explanation of how they work. But if you've never seen it before, you're not really going to get it. And if you have seen it before, there's still a chance that you might not remember it. So you use the law of sines and the law of cosines for triangles that are not right-angled triangles. If you have right triangles, you can use Pythagorean Theorem and you can use trig. Do you know the double angle formula is? Osco, forget about it. No, you don't. Don't worry. No. That's too pre-calcy. It never shows up, okay? Law of sines and law of cosines are used for non-right triangles. Pythagorean Theorem and normal trig, SOHCAHTOA stuff is used for right triangles when it's super simple. These are not right triangles. Use law of sines and law of cosines. Here's how it works. Let's say that we have angles lowercase a, lowercase b, and lowercase c, and across from them we have the uppercase versions of those letters representing their side lengths. The law of sines says that any side length over the sine of its respective angle will be a ratio that is equal to any of the other side lengths over the sine of their respective angle. It's lowercase c. Lowercase c. You can also flip this if you want, and you could say sine A over A, sine B over B, sine C over C. All right. So as long as you know one of the pairs, you can solve for a missing thing. All right. Such as, let's say we had 27 degrees, and this is 4, and this right here is 64 degrees. What is this? We have one complete pair. 4 is opposite 27 degrees. So I would say that 4 over sine of 27 degrees will be equal to the other side length over its respective angle sine, okay? Cross multiply, put these in your calculator, you got it. Great. I'm not going to do it. We have other fish that are currently not fried that need to be fried, and they're larger than this fish, which is also not fried, but it's smaller. So we don't need to put effort into, which is actually a good metaphor for these questions. If there are questions that are super hard, you don't get bonus points for getting them. You just get 1 point. So don't waste your time on questions that take you a long time. The sooner you're able to identify that those are hard questions and skip them, the better, because you can get on to other questions that are easier. Lower hanging fruit, fish that need frying, okay? That's the law of sines. The law of cosines. Here we go. Law of cosines. Side length c squared will be equal to a squared plus b squared. So far it looks just like Pythagorean theorem, but not anymore. Minus 2ab cosine of c. You're trying to find some missing side length. If you know the other side lengths and you know the angle that's opposite it, you can use law of cosines. This side squared is equal to that side squared plus that side squared minus 2 times this side, cosine of the angle that's opposite the side that you're looking for. And you could also use that to find the angle if you know the third side. Okay? Yes, there's that. They typically give you these, though. I don't think they require you to know them. So I don't think, as long as you're able to like substitute the right values and solve for the thing you're trying to solve for, you should be okay. That's trig identities. All right, reading tips. I got a good one for you guys. Seriously, though. It's like a little cheat code. You guys are going to love it. Okay. Jutman's excited. All right, the reading and science section are difficult to finish. The ACT is a test of efficiency, speed. All right, the SAT gives you more time, but the questions are harder. It's a little more complex. You get multiple topics jammed into the same question that you have to know how to do. The ACT is a little more straightforward, but they don't give you as much time for each question. That is the trade-off. So reading and science often are difficult to finish. Do you remember combinations and permutations? All right. I'm starting to get, I'm off the screen, which means it's time to update the queue. Cue update time. Cue update time. Time to cue the update for the update the cue. I know who I want to update the cue. Cue the... You guys are making me go crazy here. I haven't hummed closing time like that in years. Not since the accident. Anyway. When I sing like that, it's just closing time. I'm just singing. I actually am using this whole thing as a platform to launch my music career. I just thought that this is an unconventional way to get noticed. If I get enough high schoolers watching me sing, specifically closing time, I can figure it out. The places. All right, reading tips. Or more specifically, a reading cheat code. All right. In general, the reading section is about finding textual evidence to back up your answers. It's not about reading everything and then just being like, no more, time to look at the questions and try to remember everything I read. It's a constant process of going back and forth, saying, oh, this question is asking me about this dialogue between the mom and the daughter. Let's look at that again. Oh, she says this, that matches that answer, okay? Textual evidence, that shouldn't be a big situation for you. But the timing is difficult. If you had plenty of time, you'd be able to get all these questions right, but you don't. So there's got to be ways to minimize your time. For some people, it's skimming. There's certain strategies you can do to skim. And I wouldn't say try any new strategies tomorrow morning that are significantly different from what you've been doing. But this is a thing that I would still recommend you, if you can just get your hands on a reading section tonight and just try this, just to see what it feels like, okay? Here's what it is. So you've got your paragraphs. Then you got your questions. Okay. Some of these questions have line numbers in them. You know, the conversation in line 47, what do you think they meant when they said this? Usually there's 2 to 4 that are line numbers. So let's say we have line 7, line 42 to 45, and let's say third paragraph. Okay? What you're going to do here is when you first open to your passage, don't start reading. Immediately look at your questions. Don't read the questions. Scan over them to look for these, for line numbers mentioned and paragraphs mentioned, okay? Underline them. Then go to the passage and mark those lines. Line 7 is right here. Line 42 to 45 is right here. The third paragraph is right here. I recommend a vertical line next to it. You don't want to like actually underline all these lines because it's going to take too long. A vertical line is the easiest, okay? Here's where the fun part is. Start reading. When you get to the first marked line, as soon as you read that text, do that question immediately. Do it immediately, then come back and keep reading. Here's the advantage. If you were to read all of this and then come back to here and say, oh, line 7, what was that about again? You're going to go back and you're going to read it twice. You're going to read it twice, and that's time that you don't have. If you read it once and while you're reading it, you know that there's a question about it, and then immediately do that question, that's when it's fresh in your mind. You only have to read it once. Is this the test version, same for the whole world tomorrow? I don't know that. That's a good question. I'm not sure internationally how it works. Sorry. All right. You've done question 2. Then you come back and you keep reading. Look at this, the third paragraph. I marked that. Once I'm done with reading the third paragraph, I do that question. Great. Done. Keep reading. Keep reading. Line 42 to 45. Do that question. Great. Done. Keep reading. I finished reading. I've already done 3 of the questions. I have 7 more to do. Then it comes back to the normal strategy. What is this question asking about? Oh, yeah, it's about the farm that they used to work on, and that's where they talk about that right here, and okay, that matches that answer, and things like that. This is going to shave off, in total, a couple of minutes, which can be huge. If the test is only 35 minutes, that's how long the reading section is, this kind of strategy can be huge. Totes crucial to getting a sick grade bras. All right? That's the speed strategy right there. I would say do not just whip this out tomorrow morning. Try it on a test that you see tonight. if you can find a reading section. But also go to bed because it's getting late. Don't stay up too late. What did they ask me about? Oh, combinations and permutations. Okay, that's right. Perm plus comb for your hair. What time is it? 10:33. Okay. We're getting late here. You guys need to start going to bed. Yes, Ridvik, I can explain it. Okay. English. 45 minutes. 75 questions. Math. 60 minutes. 60 questions. 10-minute break. Get up, go to the bathroom, eat the snack that you brought with you, drink the water that you brought with you. If you don't have to do any of those things, get up and walk around. This is a time for you to get your brain out of the mush that it's in, okay? So make sure to bring food, make sure to bring water. It can be a huge, huge difference when you don't have enough fuel in your brain, all right? Then you come back for reading. 35 minutes, and then science. 35 minutes. That is the test structure. Very good. Okay, we're going to talk permutations and combinations. If there's anything else you guys want to talk about, speak now or forever hold your peace, because I need to go to bed soon. And you guys need to go to bed soon more than I do. I probably will stay up a little bit. But you guys, when people say take care, is that proper? It's just it's an idiom. It's just a little phrase of the English language, and people understand what that means. There's a lot of weird things that we say, but like they're generally agreed upon phrases. So take care, means take care of yourself, which is a nice thing to say to someone. That's what I think. But that wasn't very random, Eric, because I actually knew you were going to ask that. So the opposite of random. I could see it. Probability. Yeah, we can do that. We can do that. Can you give a couple examples of complicated comma questions? So now all the questions are coming out, huh? How do you write backwards so easily? Very good, Sky Reaper. Very good. Well, my business partner, who's not here right now, who's my streaming partner, he and I took a couple years off and we went to Nepal and we studied the art of writing backwards with a very specific sect of Buddhist monks, and it took us several years to get it down. But now that we have it down, we came back and decided to teach the ACT because that's what it was all for. And if it wasn't that, it's because our camera software flips the footage. So you choose. Yeah, okay. So, okay. All right. Combinations, permutations. If you have a bunch of little kid blocks with the letters on them, you got 3 of them, not a bunch of them, you got 3 of them, and you want to put them in groupings of 2, and you want to say, how many groupings of 2 can I make? Let's make some. We could put A and B together. That's kind of fun. We could put B and C together. That's also kind of fun. We could put A and C together. Any more? No. Those are the different ways you can combine them. There are 3 different ways you can combine them. What we just made are called the combinations. You take objects from a group and you assemble them into different groups and you figure out how many groups you can make. Okay? Combinations. Now, what if I cared about the order that they were put in? So what if AB could also be BA and CB and CA? That's great. Now we're talking about permutations. So we have 3 combinations, but as soon as order starts mattering, we now have 6 permutations. All right? So permutations, order matters. And as you can see, if order starts to matter, you're going to have a lot more possibilities. Combinations are less possibilities, permutations are more possibilities because order matters. Okay? Permutations sounds like a more complicated deal. because it sounds kind of robots and I think of Rubik's Cubes, permutations, and computers and sci-fi and beep boop and aliens. That's permutations in my mind. Combinations that's a nice word. I've heard that word a million times. So the more complicated one is permutations. That's the one that's going to have more possibilities. Order is going to matter in that case. Okay. So there are two different functions here. There's the combinations function and there's the permutation function. These are available on your calculator. Find them. There's a formula for them. The formula is it's not worth learning tonight, okay? The formula is built into your calculator. N is the total number of objects. R is the number you're picking. All right? So this one here, we have 3 objects and we're choosing 2 of them, and that gave us 3 possibilities. Permutations, we had 3 objects, we're permuting 2 of them, and that gives us 6 possibilities. All right? We're going to do a couple practice problems just to see where this goes. Okay. Let's get rid of this. Let's get rid of that. We don't need that. It's not working for anyone. Because it's selfish. It only works for itself. Eric, yes. I knew you were going to ask that. I've known that since the beginning of you watching our stream, however long ago that was. I just knew it was a matter of time. Okay. Very good. So, ice cream. We all like ice cream. I do not scream for ice cream, though. I do not. There are 27 flavors. Very fun. That's very fun. We are going to get a cone with 3 flavors. All right? The order of the scoops does not matter. Doesn't matter. How many different possible cones could we order? That's the question. If the order of the scoops doesn't matter, permutations are out the window. We don't care about that. All we care about is combinations. Vanilla, chocolate, strawberry is the same thing as strawberry, chocolate, vanilla. We don't want to count them twice. Okay? Combinations is our situation. The total number we're picking from is 27. The number we're choosing is 3. 27 choose 3. Put this in your calculator. I'll tell you what it is. I will tell you right now. So it's usually under math, you go to probability. Here we go. Combinations. And it is 27. Where's the comma? 27, comma, 3. Enter. 2,925. All right. Now, what if the order the scoops were in does matter? That means it's permutation time. 27 permute 3. It's going to be a lot more. Probability, permutations, 27, comma 3, enter. 17,550. Yes, permutations. All right. Ooh, okay. Let's turn that off. That is the main difference. If there's a particular permutations combinations problem that you want me to answer, please ask it. Otherwise, I'm going to continue on to probability. Or as people who speak Spanish say, probabilidad, I think, probably. Usually that the TY becomes a dad because it has a kid. That's how you become a dad. Okay. I gotta let it dry. You gotta let it dry. I don't know why I didn't also. Let's clear that too. Which one's wet? They're both wet. Great. This is a disaster. You gotta have a wet rag and a dry rag. I have 2 slightly damp rags, which is helping no one. Okay. Now it's wet. There. Okay. Let's clear up this board. Let's get some real estate. Let's start selling this real estate. Let's put a nuclear power plant behind some of this real estate. Watch the value go down, even though they're very, very good for society because they have much less of a greenhouse gas impact. You're just going to deal with the waste. Nuclear waste is that's a problem. Sorry about the late question, but can you really fast over sequences in series? Yes, I can. Yes, I can. All right. That is the last question I will go over, though, because you guys need to go to bed. Probability. With dice, or just a die. Probability in general is desired over total. How many options do you desire? How many total options are there? The probability of rolling a 1. How many options are 1? Just 1. There's only one option with 1. How many total options are there? 6. 1 out of 6. Now don't get me wrong. The 1 here does not mean the 1 there. The probability of rolling a 3 is also 1 out of 6. It is one desired option out of 6 equally likely options. All right? Here's where things get fun. The probability of a 4 or a 6. Or means add. Or means add. This means probability of 4 plus probability of 6, which is 1/6 plus 1/6, 2/6, 1/3. All right? There are two options that satisfy this. If the only thing we care about is, hey, a 4 or a 6, I'm fine with either. There are 2 desired over 6 total. That's 2 out of 6. That's 1/3. All right? Or means plus. Now, different situation. They're usually just and, but I like to call them and then because it makes it easier to imagine that there are 2 different events here. We're going to roll it once, then we're going to roll it again. So what's the probability we get a 2 and then a 3? And means multiply. Probability of 2 times the probability of 3. 1/6 times 1/6, 1/36. Okay? And then means multiply. 2 separate events, multiply their probabilities. One event, a couple options that are both cool, add the probabilities. Okay? So here's a question. There's a sack. Sack's got marbles in it. You know, marbles. 5 blue. 6 orange. 2 pink. See what I did there? The colors. Very fun. All right. What's the probability of 2 blue marbles, then orange? This is 3 events here. We pick a blue marble, we pick another blue marble, then we pick an orange. If it's and then, it's all going to be multiplied. So the probability of getting a blue marble the first time. There's 5 blue to pick from. There's a total of 13 marbles. Great. We picked that blue marble. Now, if we pick that blue marble, the bag has changed. We have 1 less blue marble, and there's 1 less marble in total. And this is if we do not replace the marble. Because they might say with replacement, in which case we put it right back in and we're back where we started. If we don't replace it, we have 1 less of everything. The chance of getting another blue marble, there's only 4 to pick from now. And there's only 12 marbles to pick from in total. That's our new probability. And then orange. There's always been 6 orange. But at this point, there's only 11 marbles left. Multiply all these probabilities together. You'll get your answer. Eric TLT, 20 students in the class, 11 are boys, 6 boys have black hair, and 5 have brown. What's the probability of picking a boy who has brown hair? Very good. Okay. are you picking a boy for sure, or are you just picking a random student? And you want to know the probability that that random student is a boy who has brown hair. Because you might see a question that says, given that you're picking a boy, what is the chance that the boy has brown hair? Or you might just say, one student at random is picked. So which one do you mean by that, Eric TLT? Because those are two different questions. Oh, man. Random. Okay. So desired over total. How many boys have brown hair? 5. How many total students are there? 20. 5 brown-haired boys over 20 total students is 1/4. That is what you would do there. Or means add, and then means multiply. Or means and then means multiply. Stop on your right foot. Don't forget it. Now it's time to bring it around town. Bring it around town. Then you do this, and then this, and then this, and that, this, that, this, that, this, that, this, that, and then... If you guys didn't watch SpongeBob growing up, then these references are going to be so strange to you. I'm not just randomly making them up. Even though you probably wouldn't put it past me to just randomly make them up. But they're SpongeBob. If anyone's watching that used to watch SpongeBob and just wants to let me know that you're understanding my references, I'd appreciate it if you said something. If not, it's a sad world. Yeah! Yes! Good, Sky Reaper. That is a good... Oh, good, Chutman. Good. Good, good, good. It connects me to the youth. Yes. Yes, Eric TLT. I get most of your references. Fantastic. Okay, good. That makes me a lot happier. You are also a cultured individual. Oh, so are you, Sky Reaper 212. Well, Jutman, the question that I was asked is there are 20 total students. The probability of picking a random student who is a boy that has brown hair. There are 5 boys that have brown hair. So that's 5 out of 20. Unless there's information I'm missing, it's 5 out of 20, which is 1/4. 11/5? 11/5 is over 100%. The probability of something cannot be greater than 100%. 11/5 is, that's 220%. So it can't, maybe you're thinking 5 over 11. But again, the probability is picking a student at random, not picking a boy and wondering what the probability of that boy is of having brown hair. Highlights, my bad. Yes, Jutman, that would be the situation where, given that you're picking a boy, what is the probability that the boy has brown hair? The question here is you're picking a student at random, which includes the girls as well. There are 20 total students you could pick from. Only 5 satisfy what you're looking for. So it depends what the question is. One of the question's answers would be 1/4. If the question was slightly different, it'd be 5/11. Okay, comma time. I'm just going to go over the 4 comma uses. 1, listing commas. Well, Jutman, the question was picking a boy who has brown hair, not a question of picking a boy or someone who has brown hair. Now, that's an interesting question, if it is a boy or someone who has brown hair. Because actually, there's something that happens in that situation that we do want to talk about real quick. I'm glad that you brought that up. That is a slightly different question, but let's talk about it. 20 students. 11 boys. So 9 girls. We have 5 brown. 6 black. And from the girls, let's make up a number here. Let's say that there are 2 brown. Okay? Which means that there are 7 black. So, if the question was the probability of picking either a boy or a brown-haired individual. You'd think or means and. So that's the probability of a boy plus the probability of brown hair. Let's see if that works. Probability of a boy, 11 out of 20. Probability of brown hair, well, we have 5 brown-haired boys and 2 brown-haired girls, so that's 7. So that would be 7 out of 20, which would be 18 out of 20. We're done. No, we're not. No, we're not. Something happened here we have to keep in mind. All right? Being a boy and being brown hair is not mutually exclusive. There's overlap here. Let me think about it. Does that make sense? Boy and being brown hair is not mutually exclusive. Yes, that's right. These are not separate things because there are some boys that have brown hair. And what we just did is we double counted some boys. Okay? So if you were a boy, if you have brown hair, or if you're a brown-haired boy, you satisfy this. There are not 18 students that satisfy this because there are a bunch of kids that don't satisfy this. In fact, think about the one grouping of kids that doesn't satisfy this, which is girls with black hair. There are 7 of them. Everyone else satisfies this. These 11 boys are boys. These 2 brown-haired girls have brown hair. So if 7 is not okay, there are 13 kids that are okay. The real answer should be 13, but how do we get there without logically figuring this out? Here's what's going on. If you have 2 events that overlap, we got boys, we got brown hair, and we have some overlapping boys that have brown hair. The probability of A or B is going to be probability of A, great, plus probability of B like normal, minus the probability of A union B, which is the middle. How many boys have both? 5 of them. 5 students are brown and boys. So we have to subtract that because we just double counted them in the middle. So we have 11 plus 7. Wait. Probability of brown. I said 2 girls were brown. Okay, hold on. I screwed this up from the beginning. Boys plus 2 brown-haired girls. Hold on. Oh! Wait. That's why. Yes, that was the probability of brown. Okay, we're good. There are 7 brown-haired students. 5 brown, 2 brown, and then they're okay. Great. 18 over 20, that's A and B, but we have to subtract the middle, which is both of them, which there are 5 brown-haired boys. So if we subtract from all the brown hairs, thank you, RTLT. That's absolutely right. If we then subtract, so we have 11 over 20 plus 7 over 20 minus the intersection, which is 5. That is what's going to give us 13 over 20, which is what we should have. So be careful. If they're overlapping, you have to subtract the center, the intersection. Okay. Comma usage. Listing commas. To have a list, you have to have more than 2 things. If you only have 2 things, all you need is the word and. Oranges and peaches, not a list. Oranges, peaches, and apples. You got yourself a list. Great, that's listing commas. Put commas between all of them. You can put a comma before the last and. So, come on. Great, oranges, peaches, and apples. This last comma before the apples is what's called the Oxford comma. Certain people don't like it. You like it. It's fine. They won't test you on it. It's not something that is something you could change on the test. And you're going to see it, and it doesn't mean it's wrong. It's right on the test. People that make the test like it. But don't worry about it because it's not tested. Okay. Oof. getting late. It's getting late in here, so study for the ACT. I am getting so tired, I should probably go to bed now. Whoa! Getting a workout, man. This right arm of mine, it's gonna be huge. Actually, I probably will be sore tomorrow. It's a lot of stuff to erase. Great, listing commas. Next thing, comma fanboys. We talked about this. Comma fanboys are used to separate two independent clauses. Fantastic. No, I can't. Say Sabri 917. This is for you. I'm only here for the comedic references. Oh, Garen Spurlock. You are just a little nugget of fun. You're a fun nugget. Comma fanboys, we talked about that. The next thing is separating non-essentials. All right, when you've got a part of the sentence that's not important, you separate it from the rest of the sentence, okay? If you can take it out and the sentence is fine, it's a non-essential. It's getting late. Look it up. I don't know. And the last thing, dependent clause, comma, independent clause. Let's talk about that for a sec. A dependent clause is almost a sentence. So let's say, I run to school. That's a sentence. That's an independent clause. Fantastic. If I put while in front of it, it is no longer a complete sentence. This looks like my right hand. This is actually my left hand because the camera is flipping the footage so you can read what I'm writing. Yeah, this is my left hand. And also, this says nerdish, but if you were actually here in person, you realize it says nerdish backwards. So that's also kind of fun. While I run to school, no longer a sentence. It's no longer a complete idea. While you run to school, what? You can't call this a sentence. This is a dependent clause. It depends upon an independent clause. While I run to school, I listen to Childish Gambino. There, that's a reference. I do like him a lot. While I run to school, listen to Childish Gambino. DC, comma, IC. That's great. Now here's something fun. If you reverse the order, you wouldn't need the comma. Commas represent pauses. So while I run to school, I listen to Childish Gambino. If I were to write this or say this in the opposite order, I wouldn't take a pause. I listen to Childish Gambino while I run to school. There's no need to pause there. So if you rewrite this independent clause, dependent clause, no comma is required. All right, sequences and series, and then you guys need to go to bed. Especially you. You know what I'm talking about. You know who you are. I don't need to say it. I don't need to say it. Well, before I do that, there is one comma situation that I think screws up a lot of students, so I do want to talk about that. Which is this. Jenkins. Oh no! Oh no! Everything I touch dies! Alright. Yeah, it kind of does. I see that. Neo-Socratic, your second semester senior. Oh, man. Dude, I'm like a... Oh, hold on. I'm like a 16th semester senior. And I'm here too. So, you know, join the club. Team leader, Eric Jenkins, loves tacos. The question here is, are these commas necessary? Old man Jenkins. It was his hat, Mr. Krabs. He was number one. Although that was Smitty, Von Bergen, whatever. That wasn't Old Man Jenkins. These commas are boxing Eric Jenkins in. So the question is his name an interrupting element? If it is, we're all good. If it's not, we have a problem. Sure, so fun. Sabri, you're so fun. You're so fun. What are you doing? You're fun. Oh, we try to make this stream fun, free, and flirty. So that's what this is. Okay. Is his name interrupting? It is if you can take it out in the sentence, it's fine. Let's try it. Team leader loves tacos. That's not okay. It is essential here. Because you could not take it out. The sentence would sound weird. Team leader loves tacos. You can't say team leader loves tacos because team leader is not an appropriate subject. If you said the team leader loves tacos, then I'm on board. Then you can take out Eric Jenkins. That's great. The commas there will stay because his name is interrupting. The team leader loves tacos. That's great. As long as that the is not there, Eric Jenkins is important. It is not interrupting. You have to take out the commas. It is essential. Team leader Eric Jenkins loves tacos. Okay? All right. Let's wrap this up. Sequences. They're patterns of numbers. There's an infinite number of different kinds of sequences where you can take a square root and then multiply by 7 and then add 3. And you keep doing that to get the next number. There's two in particular that this test wants you to know. Would team leader Eric Jenkins love tacos? Well, okay, there's two problems with that. Number one, the subject is still team leader Eric Jenkins, so the verb would not be love tacos. It would be he loves tacos. Unless you're talking to him and saying, hey, team leader Eric Jenkins, love tacos, like a command. If that's the situation, then you're right. But if that's not the situation and it should be loves tacos, that comma there would not be right because you're separating a subject from the verb. You never want to do that. That's one place you do not want to have a comma is between a subject and a verb. Okay? I, comma, am happy. Don't want to do that. There's something very sacred about Neo-Socratic. A comma splice is actually not that. A comma splice is when you have two sentences and all you have is a comma between them. It's not cool. You got to put a fanboys in there. Comma fanboys is good. A comma by itself, not okay. So Jutman, does that make sense? You cannot put just a comma there because you're separating the subject from the verb. You don't want to do that. Good. Unless you're shouting at team leader Eric Jenkins and forcing him to love tacos, which is a hilarious image. Who don't like tacos anyways. I like that. All right, two kinds of sequences. Arithmetic sequences and geometric sequences. Arithmetic sequences, you are adding or subtracting something over and over and over again. All right? Every single time I'm adding 4. That's what's happening. I walk is an independent clause, right? Yes, it is. I walk is a full sentence, subject, verb, complete idea, you're good. Yeah. This is an arithmetic sequence. We're adding 4 each time. The number that you're adding each time, we call that the common difference. The student today asked me, wouldn't it be like 11 minus 15 because it's a difference? It's the other way. It's 15 minus 11 is positive 4. Just think of the common difference as whatever you're adding each time. All right. In this case, D is equal to 4. You could be subtracting. It could be going down. It could be 19, 14, 9, 4. In which case, the common difference would be negative 4. Negative 5. Sorry. Negative 5. Okay. One thing that they're going to ask you to do is they're going to give you a sequence and they're going to say, hey, what's this term? All right, so let's say we have 4, 10. This is easy. We must be adding something twice to get to 10. All right, you could play around with it. There's 6 distance units between these, so halfway has to be 3 distance units, just 7, okay? That's not too hard. What gets hard is when you start getting into this. All right? Here's what you can do. You can try your best. You can make some guesses, or you can approach this algebraically. Remember, we are adding some number D every single time. So this is 4. This next one we're going to get by taking 4 and adding D. So we're going to call that 4 plus D. If we add another d, we have 4 plus 2d, 4 plus 3d, and this place where 17 is could also be written as 4 plus 4d. So let's set those two things equal. 4 plus 4d is equal to 17. Subtract 4, we get 4d is equal to 13. D would be 13 over 4, which would be 3.25. That's our common difference, 3.25. So every time we move up, we're going up by 3.25. Now we can fill these in. I'll put them underneath. This is going to be 7.25. This is going to be 10.5. This is going to be 13.75. That's going to be 17. How many more questions do you have to answer until you can get to my draft corrections? Ace Chess, we're not going to do that. We're going to send you a private message. This is ACT cramming session, so that's not what we're doing right now. One last thing you have to know about these is, let's say they give you, okay, I'll put it over here. Let's say that they gave you, okay, -3, -17. So what is that? What are we going by? 14's, -31. Okay? That's the 7th, 8th, and 9th term. So there's a bunch of terms before. And let's say they wanted you to define the 21st term. You do not have time to find all of the terms in between. You just don't. Okay? Instead, you have to approach this algebraically, like normal. Every time you move forward a term, you're subtracting 14. All right? From the 9th term to the 21st term, how many jumps are we making? This is a jump. How many jumps are we making? Well, 21 minus 9 is 12. 9 plus 12 is 21. You're going to make 12 jumps to get from 9 to 21. All right, I figured that out by taking 21, I just subtracted 9, and I get 12. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 jumps right here. And each of these jumps, what grade do they teach this in US? It depends on the school. It depends on what level you're in. Sometimes kids take pre-algebra in 8th grade. Sometimes they're already in algebra 2 in 8th grade. You know, I don't know. It's somewhere between 6th and 11th. It depends. Every jump you make, you're subtracting 14. So to get from the 9th term to the 21st term, we're going to start with the 9th term, and we're going to subtract 14 12 times. All right? Subtracting 14 12 times. That'll get you to the term you want to get to. I'm not going to do it because my bones... You obviously took it in 6th grade. Oh, yeah, Sabri? Well, you obviously took it in 6th grade. How does that make you feel, huh? Telling me that? How do you think I'm supposed to feel about that? Okay, so number of jumps, common difference. Great. Geometric sequences, and then we are donezo. Dunzo garbanzo beans is the expression I want to use. So I'm trying to make that catch on. You are the nerd here. The nerd. He knew this right out of the womb. I did partial derivatives in the womb. You guys are a bunch of bozos, and I love it. Can you take the SAT when you're already in college? Yes, you can. You can take the SAT as an adult. I knew a group of people who they had this bet every year, and whoever lost the bet had to actually take the SAT, and then like send everyone their scores. So they were adults. And they were like, well, I don't want to get a bad score and embarrass myself. So they actually like studied for the SAT if they lost the bet. I forget what the bet was. But anyway, it was pretty fun. It's pretty fun. Here we are, wrapping up. Wrapping up right now. Geometric sequences, then we're donezo. Garbanzo beans. Arithmetic, you're adding or subtracting. I have a 3-year-old kid. He's so dumb. I should get him to your school. I don't have a school. This is the school. This is the school. He's 3 years old. Give him some time. You don't know if he's dumb yet. Even dumb kids aren't dumb. They need someone who can explain things well to them. You can tell it's getting late in this chat. Yes, you can. Yes, you can. All right. He doesn't recognize me. Isn't that dumb? Have you brought that up to like a medical professional? Because that actually sounds serious. I don't think that's a sign of intelligence. I think that's a sign of he can't, I don't know, maybe his eyes, there's a problem with his eyes or his visual systems or something. So I wouldn't just call him dumb because of that, because that sounds rather serious. All right, moving ahead. Geometric sequences, we are multiplying or dividing. So, okay. What are we multiplying by or dividing by? Adding and subtracting are two sides of the same coin. Subtracting by 4 is the same thing as adding -4. So multiplying and dividing are the same deal. All right. What's the relationship here? Well, we're clearly dividing by 2 over and over. What is that in multiplication? Times 1/2. We're multiplying by 1/2 over and over and over again. Okay. So the number here, last time it was called the common difference. R is the common ratio. That is the number we're multiplying by again and again and again. In this case, our R is 1/2. So we got 4, 2 spaces, then 0.2. How do we figure out what those are in the middle? Your goal should always be, let's find the common ratio. It shouldn't be just like, what could those numbers be? It's like, how do we get from 4 to 0.2 in 3 jumps? That's the idea. All right. We're multiplying by R every single time. This is the R for that, obviously. All right. So algebraically, what fits here? Well, we'd start with 4 and multiply by R. This will be 4R. What fits there? Will there be a sequences where the second ratio difference is the same? Treehouse Masters sounds entertaining right now. I don't know which Treehouse Masters. Where the second ratio difference is the same? I'm not sure I understand what you're saying. The second difference is the same. The second ratio is the same. I mean, in sequences, the ratio doesn't change, nor does the difference. If the difference is +4, it keeps doing +4. Neo-Socratic, yes, 4r squared, which means what goes here is 4r cubed. If we set 4r cubed equal to what our actual term is, which is 0.2, we can solve this thing. R cubed is 0.2 over 4. What is that? 2 over 40. 1 over 20. We're taking the cube root of 1 over 20. Let's see what that is. And what time is it? 11:15. Oh my god. What is going on? This is insane. Okay. So 1/20th. I'll take that to the cube root. You know what I'm talking about? All right. All right. That is approximately, come on calculator, do your thing. 0.368 with some change. All right. Grin Spurlock, get that bread. You've got this. Well done. I like the difference of the difference. Oh, okay. Well, okay, Ridvik, that would not be a arithmetic or geometric sequence anymore. That would be a different kind of sequence. And yes, that's possible. They'll give you a definition for it. They'll give you a formula for it. So yeah, there are sequences that are like that. And what those end up being are typically some kind of exponent is involved in that. Yeah, I can't think right now. All right, so we can plug this in now. 4 times that. This is going to be 1.47, and then times another one of those. Oh no. Is going to be 0.5431. End of. I'm kidding. No, I mean I probably should have done it just now because that would have been cool. So Lastly, for example, 2, 4, 8, 14, 22, the difference is 2, 4, 6, 8. Yeah, it's a good idea. Let's think about that for a sec. Red Vic, I'd have to think about this for a little bit. There's a formula for this. This is not a name. There's not like a name for this particular type of sequence. I don't think there might be. I don't know. I'm not an expert here. But if we're not doubling, that's the interesting part. We're adding. You're starting with 2, and you're adding whatever position you are. There's no way this is right. This is the first term. This would be the second term. For the second term, we should get 4 from this. 1. No. First term would just be 2 plus 0. Good. The second term would be 2 plus 2 is 4. The third term, 2 plus 2 times the third term, it's 2 times 2, which is 4 plus 2. I don't think Eric TLT. Eric TLT, get out of here. I don't care. I'll think about this later. The last thing we did, it's similar to what we did with the arithmetic sequence. We got the 8th term, the 9th term, the 63rd term. Seven, 7.6. First thing, as usual, find your common ratio. In order to get from 7 to 7.6, we just divide the 7.6 divided by 7. 1.085. Our ratio is 1.085. To get from the 9th to the 63rd term, we have to think about the number of jumps we're making. 63 minus 9. 54 jumps. Every jump is not adding something. Every jump is multiplying by the common ratio. So we start... God, this board's getting messy. This needs to be more wet. Start with the 9th term, 7.6. You're multiplying by your common ratio, 1.085. And you're going to multiply that over and over and over again. So use an exponent instead. We're going to multiply by 1.085 54 times. That is what exponents are for. They're for repeated multiplication. That'll get you to your 63rd term. And once you're at your 63rd term, never leave. Stay there forever. All right, I am kind of up for a challenge, so I do want to figure out the formula of this thing. And then I swear I'm going to bed. I'm actually probably going to play Mario Kart with my roommate, so don't quote me on that. Let's get rid of all this stuff. It's all going by the wayside. The wayside. Oh, the wayside. Okay. All right, this isn't too bad. Whatever the term is, okay, so you're adding 2, 4, 6, 8. So the second term is plus 2. This is the, and then you get plus 4, and then plus 6, and then plus 8. Okay, Jutman, good to have you on stream. Jutman, are you the one that... Oh, no, it's Ridvik. Okay. Akash Adavel, you asked about the nth term. You asking about a formula for the nth term? I'll give you a formula for the nth term. Give it to you right now. Arithmetic. Geometric. Ridvik, I won't forget about you. You're the first thing I'm going to do. I'll send you the program. I want to get this, though. All right, so n is equal to 1, 2, 3, 4, 5. Yep. Okay, here it is. That's n minus 1. Okay, so when n is 1, this is 0, that doesn't matter. When n is 2, we have 2 plus 2 times 1, which gives us 4. When n is 3, we have 2 plus 2 times 2, which is 4. Do you also go to Stanford? Yes. We want to add 4 to what we just had. Good, I'm glad it's helpful. Oh, it's the recursive. That's what it is. No, I can do it explicitly as well. Okay. So this is all plus 6. 6 plus 12 plus 20. We've added a total of 2. We've added a total of 6. We've added a total of 10. 10. Wait, it's not 12. Plus 2, plus 4, plus 6. You say it was 12? It's 14, not 12. Yeah. It's 14. It's 14. Is that what got me before? Okay. 6 plus a total of 12. Okay, yeah, plus 2 plus 4 plus 6 plus 8. That's better. Okay. First term, we had a total of 2, we had a 4. 6, we had a total of 12. We had a total of 20. 2, 6, what's the difference there? Multiplying by 3 times 4. I'm too tired. I admit defeat. RivKit G, your program is coming up. To all of you, best of luck on tomorrow's ACT. Contact us if you ever are thinking about some tutoring that we do online. I don't know. Maybe. Otherwise, have a good night, get some sleep, eat a good breakfast tomorrow, bring water, bring a snack, get yourself up during that break, and just give that test the business. Big time.